Hi everybody, it's Tuesday, April 11th, 2017, and once again it's the Keshe Plasma Reactor Group, and I'm here with Guy.
Hi guys.
World famous Guy.
Oh, we're suddenly.
You've heard of the artist Van Gogh? Maybe?
Maybe one day, yeah, maybe one day.
Well, it just takes a, one letter difference or something. It's not a stretch, eh? You could always just change your name by one letter, get fame instantly.
Just
think about it.
Instead of Guy, spell my name Go.
Yeah.
Yeah, why not?
Put the van in front. You could drive around the van. Call yourself Van Go.
New waves. Yeah.
That could work. It could work. We're getting desperate here, though. Let's get back into plasma. Okay, so we've got a few people. Oops, wait a minute. Before we start anything, let's record. Thank you for recording, John. I'll record to the cloud. And just to make it official for Mr. Cloud, it's Keshe Plasma Reactor Group for April 11th, 2017. There, I said it. It's done. So easy that time. Okay, so let's get started. I understand. Let me see. First of all, since Lee isn't here, we usually start with Lee, but I would like to dive right into what Mark has, actually, because I hear rumors and innuendo that there's something good coming out of the Mark end of things. Is that true, Mark? What do you got creating in your life there?
Who's telling tales?
Who's telling?
I think it's Mr. Facebook more than anybody else, but what Guy was saying, that you
we're
had something
following tales.
Following tales.
Following tales. Yeah, I don't know.
Tales of Gans and other lands.
And freezers and what is it that you want to show, Mark? Sorry, I don't want to go ahead and tell ahead.
No spoilers here. We don't want to spoil everything.
Oh, you can go right ahead. It's just you know, because I put it's on Facebook or whatever. But which one were you talking about? The bubbles from the container that we were talking about?
It was actually John that brought it up originally, I think, or it was or Shander. Shander, you mentioned it too, or who was it that was saying that with Mark's stuff? That Mark had things to show.
Well, I mean, because I put you know me, I free stuff. I don't know why, just because I think it's cool now.
So
yeah,
to speak, eh?
Well, why not?
It's cool. All right, then that's the hot topic for tonight.
Water has an extraordinary way of showing how the plasma behave or how it expresses itself. I mean, you got a cool little experiment that nobody ever done before. That actually we see things there that we've never seen before. So I like what you're doing, Mark.
Oh well, thanks, Guy. I actually took. We should be thanking Lee for just leaving his stuff out on the back porch. I mean,
yeah, he has some massive blocks of
yeah, Lee is very
showing things there. Yeah.
So that's what really inspired me. I just thought, well, one thing would lead to another. So that's kind of what happened here.
Wait a minute, Shandor, it sounds like a volcano there with your microphone.
Oh, sorry.
I
moved the camera.
Okay, yeah, it sounded like you're moving
furniture.
I just forgot to mute.
Okay, you want to show your thing here? Let's pin it.
He could go right ahead, Rick, because I'm not really ready yet. I just said
Okay, yeah. Good, Mark. Thanks.
Just very short. This is a CH3 kit, and what's interesting in it, it has a ground formation which goes from the top to the bottom. So maybe I show it with this pencil. So here you see a thread of amino acid which goes from the top straight down to the bottom. There you can see another one deeper. So this happened after several weeks, and maybe it was 3 weeks before Rome, about 5-6 weeks. So here I have a copper plate, which is nano-coated. I have an iron plate and I have a zinc plate. And I have the salt water inside. And this is the CH3 gas, which was harvested first time. This other is which was harvested the second time. And recently I observed this interesting formation. Even after I harvested, so I stirred the water, this still stayed there. It's like a solid column. It's something very interesting. I cannot explain it yet. So I hope somebody will come with some idea about.
Is that? It looks white in the picture.
Yeah, why is it so bright?
What color does it look like to you there?
Yes, it's white. So on the top there is a lot of amino acid. And here you see amino acid collected. Here was the original level of water. I just didn't refill it recently, so it evaporated. And starting from this amino acid accumulation, it started to grow down. Such long threads.
Are you sure it's not salt? Because
no, it's for sure it's not salt.
Okay.
So this is a kind of amino acid.
Does it look like? Is it
salt? Sorry.
Does it look crystalline?
So this is salt, but this is amino acid here, or something related to zinc maybe, or an amino acid combined with zinc. It's white, but it's not salt.
Okay. Doesn't have that crystalline structure to it, I guess.
No, it has nothing like that.
Interesting. Okay.
Yes. So I let it grow further. So let's see. Maybe it makes legs and wings. Who knows?
And where does it seem to come out from?
From the top.
Just from a wire. Sorry, just from
the zinc plate.
From the zinc plate itself. Okay.
Yes. Something white attaches to the zinc plate, and from that it goes extended like a thin thread, which started to get thicker and thicker and thicker.
Can it not be some zinc shedding, or I don't know how to
like
sulfate
zinc
or
oxide maybe?
Oxides or
all possible. All possible. I have not the best lighting settings now. It's the last update of the Zoom client. I cannot adjust the camera white balance and lighting, so on. It's a glitch in the new software. So what I could try for better lighting, to stop my video, to start my camera software separately and to share the screen. Just a second until it fires up. So share the screen. So here it is. Let's try to adjust the camera. I can change the white balance a little bit. Now it's around 4,000. I can change the brightness and you can see it better.
Mm-hmm.
So I'm speechless.
yeah, that's a first too. We've never seen that before.
Nice of me. Or I can put the auto, the manual focus.
Yeah, once you have the focus set, it's best not to use the autofocus because it was going in and out a little bit earlier when it was good at one point, and then it started going in and out like.
Yeah, it cannot decide to which point to focus.
Yeah.
So anyway, my question, Shandor, would be that you've been using CH3 many times before, and what makes this one different?
So what I did before, I'm not sure it was CH3 because I forgot to use zinc. I did at the beginning with zinc, and later I just put iron, following the wrong instructions, which people just copied and replicated without checking. Actually, to make CH3, you need two conditions. One condition, which is between nano-copper and zinc, is to attract carbon. So zinc it must be present. Originally, the best method is to have a zinc-coated iron plate. Not fire-coated, but such a galvanic coated, so not a very heavy zinc, just some zinc should be on the plate. And because now I don't have that zinc-coated plate, I tried with iron plate and zinc plate separately. So if we calculate, just a second, let me annotate. Let's put a black color. So if you see zinc is 65, the difference between 65 and the field strength of nano-copper, which is around 58 to 60, let's say 59, difference is 6, which is attracting the 6 protons of the carbon. So between zinc and nano-copper, we achieve a difference which attracts the carbon. And first of all, I produced some CO2 gas. And after a while, it started to produce some small hydrogen bubbles, probably hydrogen on the walls of the container. So it means the free oxygen from the salt water was depleted. Those who have fish tanks, they understand that there is some dissolved oxygen in the natural waters, and if that gets depleted, if you have fishes in the tank, the fishes die unless you pump some air. So I just waited for that moment to deplete the oxygen from the water. So I harvested all the CO2 gas, and I added the iron plate as a third plate. I connected them together with nano-coated wires. And between this copper, which is 59, and the iron, which is 56, there is a field strength difference of 3, which is equal to 3 hydrogen atoms or triple hydrogen. So this makes the condition for attracting triple hydrogen. So the carbon which you attracted into the salt water tends to combine into CO2 if it finds the oxygen, but if the oxygen is depleted and you create a second condition with iron and nano-copper to attract the triple hydrogen, and it gets combined with this H3. And the color is more orange than the previously made rusty brown color things. So I think it's not a bad way. By the way, I found this method with nano-copper plate, iron and zinc plate on a multi-language demonstration video made in Italy by Giovanni Lapadula and the team. This is a further development that we got this little column made of who knows what. Can be a zinc oxide combined with the amino acid or whatever. And you see the second one is growing here. A third one started to appear here right on the surface of the plate. This also starts from here to here. So you can see it on this dotted line. So many interesting things will appear. So now, after these have been seen, it's time to add some water to the composite, to the vessel. Because it's evaporated, so I keep the condition with water.
Have you been adding water before, Shandor, or not?
Yeah, I used to add it at every week once. Each week I added some water to complete the evaporated water.
Right.
The system is open, so it evaporates. And what's interesting, I had such a two, three similar vertical white lines here before. I stirred it and I added the water last time, but the one stronger one survived. So anyway, if somebody has an idea, please comment.
Do you think the ones that didn't survive, did they dissolve in the water, or did they fall to the bottom, do you think?
I didn't plunge into to check it in details.
I'm wondering if you could take a sample of, you know, I hate to break that nice, long, big white one up, but if you took a sample of it and then tried to dissolve it in distilled water and see if it behaves like GANs, where it would not dissolve, or would it be more like a salt or something and tend to dissolve?
It doesn't dissolve. It's more like a precipitate, something which doesn't dissolve in water. So maybe now it's broken or not. I cannot judge until it will settle down, become transparent again. So if it's broken, in that case we will see if it forms again or not. Anyway, I may harvest it in a portion of GANs meanwhile.
This is Denny. Shandor?
Yes, please.
How do you make your hemoglobin?
In no way. I didn't make it. I didn't make it. So thank you for the question. I have no experience in making hemoglobin.
This is similar.
Mr. Keshe explained for the hemoglobin that you put the nano-coated copper plate and the iron plate, and when no iron, sorry, you put let me draw it here. You put an nano-coated copper plate, then you put a zinc plate. You connect them together via an LED or with twisted nano-coated wires, whatever. And after you got not just the GANs, but when you got the amino acids on the top, in that case, you put here an iron wire which is not connected to the zinc plate. In my case, the iron plate is between them, not behind, and it's connected. And in case of hemoglobin, you just don't connect it. You just let it in, and then you will see here, according to the description, you will see here some red stuff dripping down along it. It's a slightly different thing.
Yes.
A good distinction there, I guess. Thank you, Shandor.
Yeah, you're all welcome.
Is that what made sense to you too, Denny, or what do you think?
I have found that the wire doesn't really produce as much. Sometimes I use a rebar. That really doesn't quite produce as much. But when I use an iron plate, I get the hemoglobin in a larger quantity, and my GANs becomes more of a reddish color. Otherwise, I have a little spot of reddish GANs where the wire goes, and the rest of it's white. So that's when I use a larger quantity of iron. I mean,
not all pieces of iron are equal.
I didn't hear you.
Not all the iron pieces are equal. So they may differ in the
No, that's
other
right.
composition. Some have more phosphorus, like the nails. Phosphorus makes it softer. Some have more silicon, some have more carbon. Even a tiny quantity makes a huge difference. You see, the toughest steels have about 0.5 to 0.8% carbon only. And it changes.
Right. I used cast iron for.
Cast iron has a lot of carbon. It has even more than steel.
Yes, and so I used cast iron for one test as well. Like I had a cast iron grill that I used. Now it was in a bigger container. So I have when one of the first experiments that Mr. Keshe told us about making the CH3 was use a chicken wire a chicken wire mesh with a nano-coated wire hooked to a nano-coated copper plate, and that chicken mesh had a galvanized coating, which was zinc and nickel, and also the inside of that chicken wire was iron. And by doing that, you would get a CH3. That was one of the techniques I recall that you could make CH3. Have you done that experiment?
Yes, in the past I've used that one.
And you did not like the results or thought that it wasn't CH3?
No. I like the results. It was no problem. I still have a bottle of sample.
I have a thing I should ask Rick. You don't have a co-host, but I see John is here now. Do you need a co-host?
Well, that would be handy. I thought I already set that up at one point.
Yeah, sorry guys. Computer decided to go for a holiday there for a few minutes.
Okay, I'll make you co-host again. If it complains too much, I'll make Denny a co-host.
No, that's not a good idea.
Okay.
Okay, so does anybody else have experience with the CH3 and how they make it?
Hi guys, it's Tom. How are you guys?
Hi Tom. Yeah, go ahead.
I've got experience in with a few cases. The one case was, of course, with the nano-coated copper. The next one was with the carbon sticks and with a few different, let's say, supply from outside, like diodes, like plasma, capacitors, batteries, and stuff like that. And one of my first CH3 was actually made same way like you, Sandor. Pretty much one of the first boxes. And actually, if you get something with a different color on the top, it's probably zinc oxide. Basically, gradient inside your box. I was done pretty much similar experiment in a different way. It was box after CO2. And inside this box, which was already the field for CO2 for zinc oxide, too, I will start made CH3. So I got a combination with the two fields and not physically like a piece of zinc, and pretty much same effect. The CH3 is actually fantastic. Work very well with all the magraphs. Everything is fine. And for example, the CH3 made on carbon sticks get different color. It's a little bit more kind of pastel, something like that. I think this is the plasma condition. I always got kind of suspicions when you do ganses. I was checking this in a few different cases. One case was, I mean, the most, I think the best case to check is using a different, let's say, supply. If you do on diodes or on small electric engine, you get different condition inside the box. If you do on the plasma battery, you get also different condition. With the plasma battery, when we got this plasma condition inside the box, the colors always are much more bright, much more pastel than when you use different methods. I think because you got plasma conditioning inside your box, and that's the reason why the color go completely different. I mean, not that's completely different, but different. I was done, for example, the last time. It's a very interesting experiment. I will show you guys. I got only for photography. With the ganses, I was already made 2 ganses in one container. 2 separate guns. One is CH3, and not only this is few other guns. It's like a piece of silver, piece of something, few components, but mostly is a CH3 and second guns made.
Are you trying to show us a
yeah.
video? I don't see it. I don't see your video.
Wait a moment. I look for the photography, because this is the photography. Wait a second. You see, looking, that's a fresh thing. Okay. Give me a second, please, guys. It's somewhere here. Yeah, I got it. Okay. I will show this screen now. Okay. Okay. All right, I got it. Okay, that's 2 ganses from the one pot. Everything was made inside the pot, inside the steaming pot, when I actually do nano coating process. And the secret is, I need to actually draw something. It's gonna be the best explanation. Was on the screen. Okay. All right, I got it. So that's the CO2. Okay. That's the CO2 plus zinc oxide, probably. I don't sure on 100%. That's the one thing. that's what I expect, actually, because I didn't check on the spectrography. So and this is the CH3 plus a little bit, probably zinc too, but a little bit amount, and probably plus silver, and I don't know, maybe something more inside the. This is the stuff what I got inside the pot. So that was for sure aluminium and silver, because I got a piece of aluminium and the silver inside the pot. And everything was created at the same moment inside one container. That was the pot, and the structure was, wait a moment. Okay, let's see, this is my pot. This is my chicken wire inside the pot. That's gonna be my solution. That's gonna be my coils. and all those gases come from coils. When after all this nano-coating, I put the coils to the hot water, and all the gases just come out from the coils. I collect them. So that's the bright part. The dark part is from the bottom, inside the pot. That's the secret, and everything is actually made at the same time inside one pot. That's the way how I create these gases. So I was already use this gas, this CO2 and the zinc oxide, with probably fractions of different things, because everything is made somewhere here. So the one gas actually stick with the coils, and the other stick with the bottom. So, and those one work actually very well. This one is fresh. I didn't check yet on the coils, so gonna be probably measure over the next 2 weeks or something like that. So that's my experience with the gases. The strange, really strange CH3 with zinc oxide fields, probably. I mean, probably amounts of zinc oxide here, because I think I collect something there. So that's one of my experiments with the gases. The one gases inside one pot has the same process. So
that's interesting. Thank you.
Welcome.
Well, Thomas, did you make your GANs in the beaker, or did you make it in a different container and then put it in the beaker?
All the gases was created inside the pot from scratch. Absolutely, not exactly. Sorry, was CO2 liquid plasma inside pots. I was already applying not only water, but a few drops of liquid plasma to the solution. That's only one secret.
I guess I didn't understand. When you said pot, I said beaker. Which one are they both the same thing? When you say pot,
this is one, you know what, all the gases was made inside a steaming pot. This is the same pot when I do nano coating. That's a kind of strange experiment. When my strange discovery when I start wash up the coils after all this chemical process. I just start collect a lot of guns on the bottom after all these things. So that was kind of strange situation. I just started checking what's actually happening inside the pot. My discovery was inside the pot I got something like a reactor, and on the bottom, inside the liquid condition, inside the solution, I got CH3, bunch of CH3. Very I think.
What solution are you talking about? Are you talking about a caustic solution or a salt solution?
No. Caustic solution. Caustic solution.
You have CH3 and CO2 in your caustic? That's what you're saying?
Yeah, exactly. That's when I collect the strange pictures with these two strange gases. They was collected from the one pot and was made in the same time. That was funny thing. Two completely strange gases. The one is made inside the vapor condition, the other inside the liquid condition, inside the solution with the caustic soda. It's kind of a strange thing.
Yeah, it does seem kind of strange. I don't know if they would be the same kind of GANs with caustic
or a
added.
mix of the two.
You might have sodium in there as well.
So sodium is present in both cases, the water is present in both cases. Think about the early Coke bottle experiments. You can create different plasma conditions to collect different things.
Yeah, that's the point. That's
true.
It's about how you design it, how you follow what you are doing there. Because it's one thing to make things at random and to try to guess what it is. which also adds to the knowledge. And it's a different thing if you design by using certain materials to create certain fields in order to target some desired result. Let me remind here when
I was use the CO2. I mean with magraphs. This bright guns. I mean that's what I expect is CO2 with other gases, of course, probably, but really but small amount of other gases. It
we
definitely.
have somebody, a visitor here, he doesn't speak English, but who tried to put salt water in proximity of his mega reactor. And he has several mega reactors and produce some kind of gas also. So there are many ways how to make it. Sorry for interrupting you.
Mm-hmm. And behavior. I mean, the way how these guns behave. I mean, in working condition with the magraph system and stuff like that, is absolutely fine. Everything is okay. There seems to be. That's what I said before. My kind of expectation, because I'm not sure on 100%. There should be more like a CO2. This the bright one. The dark one, most like CH3. Of course, they got same probably the same elements inside. So probably I got piece of CH3 inside the CO2 and other things. Same story with the CH3. I got piece of CO2 probably and other stuff. So the CO2 come. This is my kind of deduction way. They come from plastic bottles, because I use the plastic bottle not only inside the caustic soda solution, inside the liquid, but inside of this vapor part inside my pot. So they lay close to, for example, coils on the sticker mesh inside. So I think the CO2 comes straight from these plastic bottles. That's the reason why I collect that many on the coils. That's much, because everything is completely deconstructed to the pieces and stay inside the vapor condition. So if you made when you actually cool down your pot, the only one thing was gonna happen: the guns need to stick with something, because the let's say magnetic gravitational behavior from the gases. So the best way to stick is carbon. So the carbon is your nano-coated coil already on any piece of nano-coated copper inside your container. So the guns would immediately stick with this piece of nano-coated copper. So when you take it, and after then you need to put to the different container with the hot water, and just left them inside this hot water, and you see the water will start change the color to completely different, and you see the let's say what's the English word? You see how all these gases just travel straight from the coils to the water, and the water was on the start was completely clear, and after a few seconds they start looking like a milk, something like that.
Milky, yeah, milky is the word.
Exactly, it looks like all the gases dissolve from the black coils, which look quite amazing, because you got black coils, and from these black coils you have this whitish kind of substance inside the container with the hot water, and you need to leave the coils, but very carefully. Don't touch the coils only by this in and out cables. Don't disturb the nano-coated layer, and left inside the box for, I don't know, maybe 30-40 minutes. And a good idea, if you like left for longer, you're gonna see the extraction for all these gases, even on top of the coils, because you create something like a storm inside the box, like, I know, the snowstorm inside this water. Look amazing. and after then everything is covered up by these guns. Even you need to shake your coils a little bit to just take the guns out of the coils, because they look like you got some snow inside the box. Like this, the small toys with when you need to just shake it, and you get this kind of simulation from the snowflakes. Yeah, something like that. Yeah.
Yeah. Thank you, Eric from Denmark. And I had a long talk with Willie not so many hours ago, and we discussed a lot of things. And among that, we discussed the making of ganses. I got a lot of plasma waters around New Year, but I don't have my own ganses. And I have a strong need for creating some ganses now, and especially after Caroline, she came with this call to do something. And the thing I discussed last Wednesday with the breads set up with a Magrav on a plate and with 90 degrees turned inner coils. I find that very interesting. So I have made one, and it is in the nano coating process now. And here the idea was to excite the Magrav with the mains line, the hot line on the mains connector, and connect that to one side of probably the gravitational side of the Magrav, and in the other end have a nano-coated copper plate.
Eric, do you have the capability of showing us that in the video?
No, because I can share a drawing of the plate I place it in, so you get an idea on how the setup is, if you want.
That'd be good. Let's do that. We gotta give our audience, we have to be compassionate for our audience to give them something other than Guy and I's image here constantly.
Let's see. Oh, there's a problem with Zoom, and that is the limited capability to handle windows. It shows only 6 windows, and if I have more windows open than that, then it's a problem. So now I will close some windows so I can see the window I want to share. With a bit of luck, I will be able to do it now. I try again. That is. Yes. You see it now?
Something's coming through. Yes, we see it. Thank you.
What you see? Do you see my mouse?
I see your mouse.
Okay. So basically, this is a round plate of plexiglass outer perimeter, and there's a hole here in the middle. And what is more is the cutouts here for the inner coil that is twisted 90 degrees. So the outer coil of the Magrav, that is an ordinary Magrav connection, not the medical one, is used, the connection here. And the inner coil is twisted 90 degrees, the same way for all of them, so they don't fight each other. And so the outer coil is lying flat on the plexiglass, and I try to center the other one around the middle of the first coil. Then I have some pins here in these holes in order to supported above the surface. And here in the middle, I will have a glass with salt water, and in the glass I will put 4 different metal plates to get the 4 basic ganses: copper plate and an iron. Actually a galvanized plate for the CH3, and the zinc plate, and a nano-coated zinc plate. And then I discussed with Willy this setup, and because Brett made ganses with this setup, where it was connected to mains line at one end and the copper-coated plate at the other end. And Arman said that if we put this plate on the ground, then it would be very strongly excited, and also the ganses made this way will be very strong and very pure, because you can put the metal plates into a plastic bag and to avoid any contaminations. And we then discussed what do we get from it, and there could be some uncertainties on what ganses would be created using this method. And Willy suggested that what we could do, or what I could do, was actually to do some more work and make 3 more setups. So I had 4 setups, and then gans the coils with the gans I wanted in the middle. Because as I understand it, Mr. Keshe says that the ganses act as a filter. And from my previous experience, when you interact with the fields this way, you get some frequencies. And the fields, they are broadband, like white noise. So when you have this set up and you use that, then you have white noise compared to a metal. And what do you get from that? Willy suggested that instead of using white noise, you gans all the coils with the same gans, CO2 or CH3 or whatever of the basic ganses, because then the coils emit primarily that frequency to the middle. And according to Willy's understanding, it would create a more pure gans. We would be more sure of what will end up in the glass in the middle when we do use this method. And what also think is very important is that Brett mentioned that the gans production is very fast, and it starts instantaneously when you connect the macro to the mains. This was what I would like to discuss. What is your opinion on this?
I was about to ask you a question, pardon me. Did you say you already had an experiment you were doing, that you already had this system set up?
I say that I have made the plate and I have made the coils, but I'm in the process of nano-coating the coils. It's not done yet.
Guys, I was done something like that. Actually, I do my few ganses. Now I do the silver gans inside star formation, which is pretty much same thing, because this is the same idea. But as I see your drawing, I would change, not the change, but I would propose you one thing. If you're gonna stay with your drawing on the screen, I will do some annotation very quick.
Yeah, I'll let it.
There's only one thing when I would get this annotation. I'm just looking for the way how to do annotation on the screen.
Yes, I have to mention one thing more. These macro coils are not the original size. Normally we make, most people make macro coils with a 1.6 millimeter copper wire. Yeah. These coils are made with 1.1 millimeter copper wire.
I think it doesn't matter. The point is because you just mentioned something like that. My position gonna be something like that. The coils in this position.
You think that is better?
Now I explain you why. Because it's okay. I will draw something like. Sorry for disturbing
that's okay.
a beautiful sketch. Fantastic technical drawing. It's a fantastic job. Anyway,
it's only a few minutes to create that.
I was already lost my skills with the technical drawing, so
it's more easy when you have a CAD program and you are used to use it.
I was already out of data with all this CAD software now. I still remember the Kuhlmann table, the big one, just stencils and stuff like that. So the field inside the maggraph is like a donut, let's say this way. So if you're thinking about pointing this field, that's the way how you point it. So if you get some guns, let's say that's gonna be CO2, that's gonna be CO2, and that's gonna be CO2, and you get your container with the guns production. So that's your field. And I think you will achieve the faster time. If you just calculate how fast you're gonna produce the ganses. And yes, of course, they probably a little bit different. My ganses are a little bit more brighter, I think. But you check inside your environment, because everyone get different environment, and the ganses looks a little bit different. Actually, doesn't matter how they look, because even we live in the different places, and combination of fields inside around London when I live, and combination of fields around the place when you live change the ganses, for example, the colors and all the things. So, but the most important thing is you still got the right field from the CO2, and you transfer this field through this container. So if you're gonna change ganses top of this coil, you will also, speed up the production inside the reactor. And very interesting thing, if you're gonna do some experiment, for example, those coils gonna be CO2 or for example CH3, and try with zinc inside. So this kind of condition. I mean,
also the first thing to do would be to try the coils in one direction, and then try another experiment with the coils in the 90 degrees to that, like is shown here, and see what the difference is. See what the GANS production difference would be. That would be a great control experiment to do if you could pull that off and document it and show us. That would be excellent. If we could see if this is true with the orientation of the fields, the way we look at it here, the way Thomas has shown, which makes sense in a logical way. But I could also say, if I could just briefly try it here, just a second. Let me just annotate for a second here. Yeah, I was going to say, if it's like that, you could say the fields are actually coming out of this and out of each of these the way they are, and that they actually could connect to form a superconducting ring, perhaps, with all of them connecting together, and have it circulating around in a like a circle. And then with that activates these three reactors, and once these reactors are activated, that forms a free plasma in the center just by necessity, just because once these reactors are activated, the free plasma in the center forms naturally in the center between them, perhaps one might say. So
This is what Brett said. It was his understanding that there was a plasma ball inside it.
right, or yeah, what's called the free plasma, what Mr. Keshe's named free plasma.
I thought it was called a central core. And Eric, that's a beautiful drawing that you have, and the way Rick demonstrated I think it's absolutely beautiful. When you have
maybe guys, if you get an opportunity to check the one thing with actually this particular setup, when you get the coils with was Rick actually draw on the screen with this field, and you create free plasma because you get three coils on the one level. Let's draw on one level. That's the one level. So maybe, I mean, but this is the only free proposition. Maybe you should check one coil on the top and one coil extra on the bottom, and basically close the fields from the top and from the bottom, and you will probably achieve huge free plasma inside.
Well, I think that would be a great experiment to do. Just simply the orientation of the coils and not changing anything else with the experiment. The same GANs in the middle or the same salt water or whatever you're going to use. And everything else keep it the same. But just the orientation of the coils and just see what difference that would make, if any.
There's one good thing about this, and that is when I deliver a DXF file to a friend who study at a university here in Denmark, where he has access to a fab lab, where he has a they have a laser cutter, and I just deliver some plexiglass plate to him. Then he can cut this in a short time. So I could make another drawing with the coils as suggested before, and then I would just make one of them because
what if you had it so you cut out the outer circles of the coils out of your plexiglass and made it so the circle itself could rotate? You could put in like 3 pins or something to keep it in place, and then loosen up the pins and just rotate this to any angle you want it. Because I also wondered about, what if you had an angle more like this, okay, where it brings in the fields from outside, brings in the fields and shoots them over to this reactor, which brings in the fields from the outside and shoots it over to this reactor, which brings in the fields from the outside and shoots it over to that reactor. Right? So that's another orientation that would be interesting to use.
But what about the nano-coating wires when we move around with it?
Well, then you'd have to make some sort of connector. You could have a nano-coated flexible multi-strand wire that would connect things so that it would be easily moved without interfering.
Guys, the perfect solution is armband connection made from 1 millimeter diameter copper wire. That's all. The long strings, like I don't know, maybe 35 centimeters. They flexible enough to do whatever you like to do. Because, for example, the next very interesting thing with this with your experiment with this plate. That's when I draw. Sorry for disturb your drawings, Rick. That's why I draw here.
Let me erase, and then we'll start again.
All right, I'll erase too. Okay. The one very interesting thing what you got with this project, I'm jealous now. Because you got okay, let's see, this is the magnetic coil, magnetical coil, and this is the gravitational. So you get this fantastic option because normal position, I mean, kind of average position is something like that. So let's, if you get a flexible system, you're actually able to turn this situation to this situation. So that means you actually reverse the field completely, because this is only 90 degree, but this 90 degree change completely the flow between the coils, because you change the flow from gravitational, because that's your...
Is this viewed the same way as the rest of the drawing, what you have drawn up in the upper corner?
Because as you see, you get the free plasma and you get these gravitational coils who they actually send the signals between, and maybe if we're gonna change the position from the coils, we will create something like, you know, different fields. Maybe, I don't know, because it's difficult, you know, decide what's gonna be the difference between the fields. But results, maybe the results gonna be faster production of GANs or clarity of your GANs, maybe, because, you know, now when you got this kind of possibility, maybe you just need to turn one coil on 90 degree, and I don't know, the magic start happen. So we don't know. But this is the fantastic idea. I do normally with the star formation. Inside my star formation, I get the jar, so I get same thing like you, but in my case is let's see, it's one coil, next coil, one on the bottom. They connect with each other. And inside I got a container, a small container with gas production. In my case, this is the silver. So, but I get normal coils, same design like on your drawings, absolutely the same. But my coils are just not like yours, but this way. So my on a 90 degree. So they just pointed to the middle. So that's only one difference. But unfortunately, I can't move my coils this way like you. I mean, it's possible, but no, not exactly.
It's nice to have the you know, the CAD drawing, so that if Eric does find a difference between the two orientations, if he does that experiment, then we could easily send the CAD drawing around to other people and have them duplicate the experiment and see if they get a decided difference between the one orientation or the other, and then we can, you know, make more of a proof of that concept, let's say, of the fields, of what the difference of the fields would be.
If we consider the magnetic fields of Earth and gravitational fields direction of Earth, another version would be to have twisted these with the gravitational coils to be parallel with horizontal plane, and to have the magnetical ones to be elevated.
No, if that's possible, I mean, create something like a holder, like in a gyroscope, when you're actually able to turn a coil in every possible condition. I saw something like the gentlemen in Germany. They done something like that on a 3D printers with the coils.
Some people from France have made that, but unfortunately they dropped out of the entire.
I mean, ultimately, the coils should be suspended and not have any attachments. They should be levitating coils, powered by a levitating maggrav device.
I mean, but if you nano-coat your holders, I mean, the elements around the coils, will just keep the coils inside the stacker. If everything is nano-coated correctly, I mean, you don't need to worry too much, I think. I mean, okay, it's kind of, let's say, leakage from the energies is different element inside the stacker, but if they nano-coated correctly, everything should be right. So I think that will be fine.
But one thing I can do is I can make a cutoff, make a hole with a diameter between the inner and the outer diameter of the magnetic coil, and then I can have a ring that is between the middle and the inner part here, and glue it onto another another circular part that has the outer diameter. This way I can turn it like I want. And I can also make the laser do some pre-cuts to the two suggested position, and then I could just drill a hole to fix it in another position.
You know, Eric, because I got pretty much probably same problems like everyone with prototypes. How to stretch this flexibility to change something after when you do the first thing and you like to, you know, redesign something. And maybe good solution is create something like independent holders with the coils, and just play it with the holes and some, I don't know, some screws or something like that, and the plate with the coil is something completely independent. And you just need few plates like that and a few coils. And if you like to change, okay, this is a little bit pain in the ass because always you need to actually create new coil or something like that. But this is very handy and good thing to do, because when you're bonding new coils and you nano coat them and do all this operation, you know everything is proper, everything works perfectly, everything is fine. When you just always disconnect and connect, disconnect, connect, you always gonna disturb your nano coated layers. So the best option is just, for example, you got set the first set coils like that. So you got 1, 2, and 3 coils, and this is the first set. The next set gonna be the reverse coils, something like that. Gonna be probably pretty much, but maybe with a different angle, not like that, but like that, or maybe something different. And you only one thing what you need to do, you just need to take the plate, disconnect with this small armand connection, let's say something like that, like a small pipe made from copper wire, and that's all. And you just need to disconnect, put the new plate, connect the new plate, that's all. And wait for sometimes, I don't know, maybe 30 minutes, because you need to actually take the time to build the field, sometimes one day. I mean, depends of your field, and you got it.
Yeah, I don't know if you got what I said before, because what I wanted was the basic plate, the big plate, gets 3 cutouts with a diameter in the middle between the inner and the outer perimeter of the magnetic coil. And then I make another plate that has the diameter of the outer coil. And I make a small ring that fits within the hole of the outer plate.
You know, even
and glue it onto the plate with a coil cutout in it. Then I can turn it just like I want.
Sorry for interrupt you. If you're gonna do something like that, even like a gyroscope model, this is the place when you need to attach the one coil, the bigger coil, and this is your plate with the hole inside. When you need to attach the smaller coil, connection will be I mean, I understand the connection like a star formation. I go this way mostly, but it's always, you know, whatever you like. And this is the one coil on the one plate, and another coil on the one plate. And
I have no problem doing that. I have a 3D printer and I have the CAD program. I can draw it if I want to. But what is the idea to go away from the basic setup where you can turn the setup of the 3 coils? Because I don't think it's necessary to go into 3D. If I can create a plasma ball in this plane, that is enough. I don't expect this to fly. I just want
it depends on it depends on how far you want to take it, I guess. The other thing is, if you create a fourth reactor or fourth setup, say above these ones, and then you would be creating a free plasma in between all 4 of them, which would raise the level of where the free plasma would be in this setup, which would be in the dead center at the same level as the other ones right now. So yeah. And also, I mean, one could dream perhaps of aligning the whole setup with the the Earth's magnetic field or with the gravitational field of the Earth as well. I mean, that might be an experiment to run. You could, because the Earth's magnetic field is very seldom parallel with the surface of the Earth. Where I live in the northern climates, it's actually quite a steep angle into the Earth. And if you're at the North Pole, it would be 9 degrees directly into the Earth. So that magnetic field, that you could orientate the whole plate, the big plate, in certain angles if you wanted to try different setups to see what would happen, I suppose. But you know, we don't want to get too complicated. It's complicated enough to run an experiment with if you had 2 of these setups, one with the orientation one way and one with the orientation 90 degrees to it. That would be a major accomplishment in itself to get some results out of that, to see if there actually is a difference. Whose theory is more correct in terms of creating that GANs from a plasmatic environment, basically. It's a plasmatic GANs being created by a plasmatic environment. So what is the most efficient way to create that GANs? Which of those 2 orientations, let's say? And then if we had one of those that worked best, then we can tweak that to change some angles, change some, you know, make it closer or further away from the center, for example, would be another experiment, and so on.
May I just put my little grain of salt there?
Absolutely.
I like the idea of maybe inducing some sort of a spiral, you know?
Mm-hmm.
This is where it's self-sustained kind of a type of a plasma.
Yeah, that's what I was thinking.
Mimicking the universe.
With that third design I had, with bringing the energy from outside and shooting it to the next...
Absolutely, which needs a certain angle, actually. It's neither 0 or 90 degrees. It's it induces a slight... And that's where the variables there.
You could be completely right, because we keep thinking of it linearly, and it must be this way and so on. But
like the arms of a spiral, actually, try to induce themselves more on. I'm not totally sure about this.
Well, if you think of the toroids we've seen, like for example, the rodent coil, and they're not straight lines.
It's a vortex type of
it's a twisted
expansion
thing, though. It's, you know, the lines of force are all coming at certain angles, and they're not 90 degrees or, you know, perfectly lined up in the way that we think of it.
That's
what would happen if we took a rodent coil with nano-coated wire? Would it make a plasma like this?
Well, that's a very good good suggestion. It's something we haven't pursued. We've had some rodent coils. We've got one sitting in front of me, basically one design, but it's
that was the one
almost all the rodent coils have the wire is coated with you know, it'll have a shellac or lacquer type coating on it, high temperature coating. Yeah, magnet wire, coil wire, and so on. So that would be a good experiment, though. Mm-hmm.
I have actually made a rodent coil 2 years ago, and what I did, I printed the ring you wound the copper wire on in 2 halves. You know, when you have a 3D printer, it's no good idea to try to make a tube on it, because you have a flat surface and you have to have some contact area, else the plastic loosens from the bed, the glass plate you use as a bed for printing. So I made it in 2 halves and glued them together. And I made them with some tiny tiny points at the outside, so that when I wound the coil, these points kept the copper wire in position. So when you make a rodent coil, it's very hard to have the copper wire sit the correct place on the outer perimeter. You have seen a lot of people doing this in styropor, and then they put needles in it in order to fixate the copper wire. But I did it so I had just, if you see here the mouse, some tabs here at the perimeter, and I also made a needle to wind it. I made a needle so that I could wind all the wire for one coil on the roding coil on the needle, and then I used the needle to put on the wire, and this way I should not fight with meters of wire and take it together, take it through the hole and avoid the kinks on the copper wire. And so I just wound all. I found out how much length you need to have to wind the coil, and then I wound this on a needle, and then I could quite easily wind the roding coil afterwards.
Yeah.
And the needle was also the needle was also 3D printed.
I mean, instead of the roding coil, I was actually checked because we're probably looking for. I mean, depends of always the independent research. What we're looking for. I mean, I was looking for let's say loop. How to create loop, how to actually invite the information to just rotate inside the system and generate whatever I would like to. For example, now this is the piece of electricity, and I was actually go to check this story with the normal MAGRAPH coil. I was done some experiment. I will show you guys something. It's gonna be
okay. Then I stop share screen now.
This is Danny. I'm on a breaker here. Before you go, Eric, what kind of container are you going to set in the middle of these three?
I would like a glass, so something made of glass, and salt water and the metal plate inside a plastic bag.
Okay, that's fine. I'm going to interject what happens in a CO2 box. If you take and put cold caustic in a plastic container and sit it there, set it in that container, say even in the sun for a day or 2 days, it changes the nature of the plastic. And when you put your unit together with the nano-coated copper plate and the zinc plate and the wires connected in the salt water, the GANs happen so quickly. My very first experiment, the GANs happened instantaneously, and I was totally amazed. I said, is this what's supposed to happen? It happened like a flush of a toilet. You went, whoosh, and there was all that white GANs, just went through all the water and down to the bottom. And I was totally amazed. And I says, I wonder if I could repeat that. And so I set it about, but the container I used the next time was a plastic bottle that my distilled water came in. And so I put the cold caustic inside that water and set it in the sun, and then I took it out. And then when I made that container, I just cut off the top of the bottle, and I put my nano-coated copper and my zinc plate there and my wire. And at that time, I didn't even nano-coat the wire. I just took a stranded copper wire from the zinc and stranded copper wire from the nano-coated copper plate, and I wound them together at the top, and swish, there became my there became my GANs again. At that time, I didn't know whether it was zinc GANs or whether it was a CO2 GANs, because I was just too new to the experiment. So that's why I asked you about the container. There's variables in the container that you use, and also there's variables in what you place around that unit, even if you placed liquid plasma, say, in between those spots where the coils are, you're changing the nature of the environment. So there's just a lot of variables that you can use here. I don't even care if you use the fields of like Alex did when he placed an orange above his health cup. Okay, that's done. That's all I have to say. There's plenty of variables, and that's why I asked you what kind of container that you want to use.
Yes.
Over and out.
And I think that was a very good contribution. You know, and I tell you why I think so, because when I nano-coated this one, the coils, I did it with fire, a butane burner, and the thinner the wire it gets, the more difficult it is to do correctly. And I did not think I was very successful. And then I was thinking, okay, I have a spray with the caustic, not aluminium and all the other stuff, but just the natrium. I don't use the English name. Natrium.
Sodium hydroxide, right?
Yeah, and also the calcium hydroxide, just 7% of the solution in a concentrated form. So I looked at these coils, they were black, but I didn't like the color. Somewhere it has more the rainbow color, and it is so difficult to do correctly, because if you just give it a little bit too much, the thinner wire, it gets hot very quickly. So I decided now I will nano-coat it with some caustic. So I just sprayed it, and it was sitting in the plexiglass plate. I had it all assembled, and then I sprayed it and put it out in the sun in a clear plastic bag. And
I think that's the way to do it with that. What you just said, put it out in the sun in a baggie. That's what I've done to produce some incredibly beautiful coatings.
Because in Douglas' teaching last Wednesday, Torbjørn from Norway, he told that he do these workshops where where people can come for 5 days and do macrobes, and he only had 1 day to nano-coat the macrobes, and he told that he put some caustic on them and out in the sun in a bag. And he said that he made some beautiful nano-coat in just 1 day out in the sun. So I took that very seriously. So I put my out in the sun, and also the copper plate I put out in the sun. And I was a bit sloppy because I should have cleaned it in some solution first, as I got a receipt from Eva how to do all this, because she's very skilled. She has made about 300 different ganses, so she is in a quite fit condition regarding making ganses. But I didn't do that. I didn't prepare it. I just sprayed on the caustic and put it in the sun and into a bag. And in just 2 days, it's almost black all over. 2 days in the sun in a Danish condition where you have clouds in the sky, so the sun doesn't shine on it all the time.
Can I ask a question? Is it black, but you know, if you put a voltmeter, can you measure any voltage in there?
Resistance. You're doing a resistance check, or you mean a volts?
Or millivolts or resistance.
Right. Okay.
Well, I'm asking, measure anything.
Yeah, but to my understanding of this, as soon as you get some black layer done with this method, and you don't press too hard with the test pins.
Mhm.
Then you will get this effect that it is isolating, because the stuff you create, that is a nanocoat. It's not another thing. I think so many people have taken copper plates, put on caustic, and seen this effect.
Mr. Keshe had a saying for that. It's an old Iranian saying, not everybody who has a mustache is your uncle. Is everything which is black the same as a properly made nanocoating?
Yeah, I can test it. I can test it.
Please.
I can even when we have finished this discussion, I can go down and measure on it. But now, you know, now it's not dried. It has the caustic on it, and I am waiting for another day with sun, so I get it completely black all over.
Yeah, like Mr. Keshe has often said, it may take days, weeks, or even months for proper nanocoating, depending on exactly what you're coating and so on.
Yeah, he said take your time.
Yeah,
that's one thing.
and 1 month was typical in the initial teachings that came out on the nanocoating. What would you say about that, Armin, or others?
Could I ask Eric how he would go down and test it or look at it? To
Wait a minute. Wait, I'd like to have my question answered first. What would Armin or others say about the length of time for the nanocoating process?
Just understand why you use the hot caustic and a deep nanocoating process the first time. A minute you put the caustic in a container and put your material over there. And when you pull the hot water, in that moment, it creates a reaction. It creates the heat. When it creates the heat, first layers of molecular structure, it releases to the atomic structure. You see the GANs that you created when you collect the caustic. You see small GANs that you created in that process. Where it comes from? It comes that this molecular structure is released to atomic structure. So you already preconditioned the first layer. Out of that, the process starts. It's still creating that nano layer in this process. When you put it in a caustic in a few days, and after a few days you take it out and put it in the air. So then the process is started until it's closed in a sealed container. The process is still going because you still have an NaOH in here. You didn't change the condition. A minute you put it in the air, it starts to oxidize. It's a diamond structure. When you test it, it's a total diamond structure, insulated. And it's a semiconductor too. But you have to understand the process. The process is that when you put that hot water, you release this molecular structure right away. You create the first condition that it's a separation. After that, it grows. It's layer by layer. When you put the caustic, actually cold caustic, I only do certain matters which they react when you put the hot caustic.
May I breaker just for a second? Are you drawing something on this screen? Because I see a mouse moving, but I don't see a drawing.
I see a drawing.
I see it blue. It's a small, maybe, no? Maybe I do red here.
I'm not seeing anything. Maybe you have to, well...
If you let me to...
Are you annotating on the screen? Because I'm not seeing any of your stuff. I see a little blue thing at the top, but with the... There's nothing else coming through.
Well, when the
have to make a new screen share with a whiteboard.
Okay, yeah, let's do that. Okay.
Shall I go stop share?
I think I can do that here. So I'll start a new whiteboard. And let's start from there. There, you got a clean slate to work with, Armin. You're going to have to show us what you were drawing there because we couldn't see. It was good stuff. It's exactly what we need to be talking about and looking at here.
See, this is your.
I'm very thankful. You know, this is what I said some classes ago, that it's very nice when you come with some ideas and you discuss them, because the knowledge grows from it. And there's a lot of inspiration, and I say thank you very much for all the inputs. And especially now when Armand comes and share his knowledge, I'm very thankful for that.
You're welcome, Chris. Just understand from the beginning what you do, and it will be easy for you to handle. Then you will understand. You don't need to remember.
Could you get a little bit closer to the microphone there, Armand?
Yeah.
Thank you.
How about now? Okay, here's your molecular structure. Just beginning of the changing of the understanding. What we do. This molecular structure is tied up together. They are so close, tied up together. Now, when we put the caustic, if it's a caustic, it's Na, it's a salt, and OH is a hydrogen. We add more hydrogen. That's why we get that reaction in the water, because water is a H2. When you add the caustic, it's an OH.
I also use a bit of calcium hydroxide. Is that 7%?
KOH.
Yeah. Is that okay?
That'd be called potassium, right? Potassium hydroxide? Yeah.
Potassium hydroxide. What you do with potassium hydroxide, you add another hydrogen in there.
Calcium.
Yes. And just to check up with you, 7% of the KOH and the rest in the NaOH.
Just understand, each salt is a condition.
Yes.
Na and K, if you look at it, their atomic weight is very close.
Okay.
After this, when you put the salt and when you put the hot water, it's the reaction it starts. It's create a magnetic pool. It's because you create the heat. So it has to be released. You add the energy in it. So you release the molecular structure into atomic structure, the GANs you see. When you do the nano-coating, you already see the GANs that you already created the GANs. They are very energetic GANs because this is the first layer that you see separation. You can collect them. Mostly, it's a
What you said there, please repeat, Armand, because I didn't understand what you just said with the gases.
You already create gases in NaOH when first you do the caustic. You already do separation. You put the, in a salt water and you put the energy, correct? A little bit energy, and you still get gas. But why you think you put the energy in this box when you are nano-coating and you're not going to get gas out of it? What is it, gas? You release the molecular structure into atomic structure that you can see.
Mm-hmm.
Each individual gas, it's a molecular structure, whatever its environment was, whatever environment is created that minute when you put energy, heat, hydrogen. This is the most job is to do. This is the hydrogen that you add, the reaction you see.
And that's why we also put a little bit of aluminium foil in it, or aluminium wire.
You don't need to do that. You don't need to.
I don't need to do that. Okay.
No, just understand, in your box, whenever the minute you start a nano-coating, whatever is in the environment, that's what these nano layers, they're going to carry it. Because you put the fields into the nano-coating material. Whatever it was in the environment, because they are absorbers, they absorb what is in the environment, so they carry that field. So whatever you put in the first nano-coating, this matter, this nano-coating material will carry that field, because you had it in your environment.
Yes.
Even it carries the hydrogen field too. Because in the environment, H2O, it's a hydrogen. You add another H is a hydrogen. It has a,
Yes.
it has a Na field too. Even you wash it, even you put it in a days in a clean water, still it's going to carry the Na, the field of Na. Salt.
Yes, because it's encoded in the nanocoating now.
Nano-coating process, because this is the beginning, huh? This is where you set everything. Just look what we did. From the beginning, we put a mesh. Mesh, it's a zinc, correct? And iron, and a copper. We nano-coated mostly copper or zinc. So from the beginning, we already have the three materials in the play. We have a iron, we have a zinc, we have a copper.
Yeah, some nickel.
What's that interaction it's going to bring you? You put it in a box. You put it to mesh and a nano-coated copper.
Armin, my program just broke down and I had to restart it. I think I've lost about 20 seconds of what you said.
You can go ahead and listen afterwards about that.
Yeah, okay, thank you.
Now you put it in a salt box. It's the same materials. This is copper. And this is, let's say, the mesh. So what you're creating here?
And the mesh is iron and zinc copper covered iron.
Yes.
And then you get some CH3, don't you?
Mm-hmm. So in a beginning, you're already making a CH3.
You mean under the nanocoating process?
Yeah, you have the same metals, correct? In the mesh, you're putting the mesh, then you're putting copper, and you're putting the water hot into the caustic. And here's the caustic, huh? So
yeah.
It releases in that moment, there's an interaction, correct? What it releases in here, it's a combination of the fields.
Yes.
Carbon, you have CH3, and you have zinc in it, and you have a copper in it.
I hate to interrupt, but I'm going to. When you put the mineral salts in there, as we do now, the purpose is so that you can have all the different minerals in the nano-coated copper. Is that correct?
No.
What is the reason then?
Salt is an earth condition. Na is a salt. NaCl is another salt. NaOH is another salt. KOH is another salt. They each have different characteristics.
Those little tablets of mineral salt that you had Mark put in his nano coating, they're salts, but there are a multitude of salts.
Why you need the multiple salts?
That was the question. You were going to use that in the nano-coated copper. And
No. I use, it's a specific job. When you use certain salts, you need a specific job, what you need to nano-coat. You can, from the beginning, you already programming your copper what to do, what to produce, because you're going to put the energy in a salt water, which is earth condition, to bring it to the, again, to atomic structure, meaning the GANs, that you're going to release it. So you need the salt. You need the salt it's in an earth condition. In a, you know, the moon, there is no salt in it. So we bring in a box, we put the salt, different salts, even from the beginning. What I want to explain, you put the salt in it to create the GANs. These GANs are the first that it's released. If you look at it, they are in nano GAN state, pure. Because you create it out of the environment of the what environment you create.
Armand, can I ask you a question, Tom, on the other side? I mean, because I was done experiment with the nano coating with this few different salt was caustic soda and sometimes magnesium salt. It's a small drop, and I was check this solution to make the coils through the health station, the big one. And I was already done with normal caustic soda before. That was part of experiment. I was just trying with the different solutions. And my discovery was the field. And actually that's your explanation, the field, because I basically make the, let's say, gradient bigger, the bigger spectrum by this magnesium salt. They actually seems to be work, I don't know, the better. People feel much more stronger this unit, which was nano-coated with the magnesium salt, just small drop. I mean, inside the solution, because my way why I was applied the magnesium salt was actually very basic, because the human body, the condition of the human salt inside the human body, basically, and that was when I tried to catch, and that was my way of thinking about this different type of nano coating, the way how you're programming your coils. I don't know I get right. That's my question to you. What do you about this?
You know, you can try anything. That's why it open, how can I say, 360 degrees open. You can try whatever you like.
All right.
When you try it, you just understand what you are creating. Not blindly you are doing it. You know, just understanding with the understanding. And then you can put your experiments and show. Okay, I put this in the box. You're still going to create, if you put that nano-coated material, you're still going to create a CO2. But it's going to be slightly different, because now you add another field into your environment. You put a magnesium, you nano-coated with the magnesium. So now it's a different environment. Now this environment is going to create still CO2, because still we have already determined the metal. It's copper, Cu, and zinc. So this is our environment. So we know in this environment that we create CO2. But this CO2, because of magnesium, it will be totally different. Like, you know, we breathe, each of us, we breathe out different kind of CO2.
Yes, that's true, yeah.
It's not going to be the same. So it's the same. Now we precondition, because now it has a magnesium field in it too. So now it's the environment a little bit changed. But still its creation is CO2, because we already program it from the beginning, what you need.
Mm-hmm. Because in other case, I was done. I was followed exactly by this idea. What you say? That was idea how to programming this other fields inside the health station. And the next way was, I mean, the first nano coating was normal with the caustic soda. We had no any extra salts, something like that. Was the, let's say, primal field for CO2, kind of. And the next coating was inside the. I was just take to the different pot because I get a few different pots with a different solution. And the next bath was with magnesium salt. Was like 2 layers. Basically programming 2 layers interactions between the inside the coils, and so that was the next idea to use inside the system, because the concept was I will catch this interaction inside the system. So if I'm gonna make the spectrum bigger for the interactions, maybe I will touch faster myself inside the system. I will find myself faster.
Great.
Oh, thank you, sir, for answer.
Any questions?
Yeah, any questions for Armin here? Or shall we,
may I ask a question about, I have, I'm in the process of making a nanocoat machine. It maybe sounds overcomplicated, but my thought is I use an aquarium, and inside the aquarium I have a container at the bottom made of plexiglass, so I can pour on boiling water without breaking the glass. And I have a frame that I put upon the aquarium where I can have copper wires to hang on coils and plates or whatever I want to nanocoat. And my thought was, when we do this nano-coated process, as you have shown in the basic videos, you put on boiling water onto the ingredients you put at the bottom, and when you do that, you have it very hot in some time, and then it cools off. And I was thinking, is this the optimal thing, or would it be nice if I could keep an elevated temperature for some time? So I plan on having a plate under the aquarium with heating elements and a little microcontroller, so I can create a temperature profile over time. And I wonder, I will test it anyway, but maybe you have some suggestions on, is it good to keep it, for example, at 50 degrees for some days in order to get some more steam on the nanocoat, or should I avoid that and let it cool down? That's my question.
Just understand, the first nano-coating process is when the first minute you engage the hot water.
Armin, maybe.
Okay, when you engage the hot water into the your box, because
yes,
you have plastic in here. So the reaction that you see, that in that moment you create, I don't know, maybe hundreds of degrees of energy, like heat, that you can release this first layer of molecular structure. That pull, that heat, it creates a condition when you start a release of molecular structure into the atomic structure. Then you see the gas, because now you released it. Then the layers, if you look at it, it's not stopping. Now they, layer by layer, it goes down, but with the gap.
Yes, and it grows at the bottom in the layer between the copper and the already made nanocoating, right?
Yeah. So these layers, when you create the gap, and here is your molecular structure, there is no gap. Just, I want you to understand this very clearly. Now this gap, it's your nanolayers. This puffy stuff, stuff that is on top of your matter, which black thing that you see, it has thousands of layers.
Yes.
When you see down under the microscope, it's like this. When you cut it from the side.
Yes. Okay.
Now this gap, that this molecular structure, now in atomic structure, even they are attached to, they can interact with another one. A minute you put a little energy, it's an instant transfer to the next step. In molecular structure, you wait until the electron is vibrating to another one and another one, because they are so close, they cancel each other fields. Until this field passes, it takes the time and you have a loss.
Okay, Armin, could you explain that to a little bit again? It also addresses Jay's question, which he had earlier. He thought that the nano-coating kept electrons from escaping, then made the copper wires supercharged, and this was how you could go off grid.
No. If you have
and
this.
Wait a minute. Today, he says, I think it's the nano-coating that somehow absorbs the energy from the atmosphere. If I dip my coils in CO2, do the MagRav units make the CO2 attract more CO2 from the atmosphere but full of electrons to create the extra energy or current? I'm still confused from 2015. So if you could explain this energy that flows through the nano-coating, perhaps that will help Jay understand that it's not just electrons being pushed around that we're talking about here.
No, when I said when you put the energy in, I didn't say when you are measuring it, the nano-coating part, you have the interaction of each. That's why you measure 0.014. I'm sorry, 1 minute.
That's 0.14 volts you're talking about, or?
Yeah, 0.1 volts. You measure it here. When you put your electrode one here and one the other end of the nano-coated material, you measure a voltage.
Now, would that be like a matter level electron flow that would be measured in that case?
No. Because of this gap, now you open an interaction. Now they interact, when they interact, they absorb too. So whatever energies is around it, they're gonna absorb it. And a minute you touch it, they discharge.
But are we talking about electrons being absorbed, or is it energy? Is it like plasmatic energy, plasmatic flow?
Because you have a gap now. Now you have an interaction, because if you create a gap, now you're going to have an interaction, because
absolutely, it's like creating a vacuum in there.
Yeah,
it's,
here the molecular structure is attached to the matter in here. Let me do another color. This is unbelievable.
We have to get that animation together, Armin, so we don't have to keep going through this over and over. Keep trying to do it.
That's what I want.
I know. I'm working on it this week, actually. This is perfect what you're doing, because it's right along with what I'm trying to visualize as well.
See, the nano-coated material is like this. It's a layers. So this layer, it's already, you have a gap now. The interaction between this and this, it's huge. In here, they can't interact because they are attached. They are squeezed together in a matter state. That's why when you put the voltmeter on a matter, on a copper, you measure 0. But a minute you have a nice nano coating and you can measure until, you know, if you crash this a little bit into the nano layer and go to the matter, you're gonna measure this voltage goes to 0.3, 4, even half a volt. You can measure instantly where this come from. Where this energy come from? Is anybody tested? Go and test.
Yeah, I've tested that before for sure. That many people have seen that 0.3 volt.
Yeah,
guys, I was built the small device who actually prove everything what Armand says. Absolutely everything. With this is basically nano coated coil, McGrath coil connected to the capacitor, and
yeah, but you don't have to connect anything. All you have to do is measure a nano-coated wire, and you can get that kind of.
But this is a nano-coated system, basically. That's nano-coated system.
Nano-coated plate. Just measure it.
Yeah, just a plate. No other system. No fancy stuff. Just a plain plate.
That's true. I mean,
yeah.
You piece of wire.
Push the minus, black one. Push it into the matter state. And you will measure, you know, very high voltage. Where this come from?
It's the interaction with the fields and the environment.
Not only the environment, you have all over this gap, these gaps, all over your nano-coated material. This is the matter, huh? This is all over. So all the collective, because they absorb and they interact, you collect that in the matter state. The matter state is the lowest state, correct? So the higher it always gives, the lower. That's why you receive a huge amount of energy that you can collect when you push it to the matter.
And that's why you can measure it with a voltmeter, because it goes to the lower state, the matter state.
Yeah. What you measure from a nano-coated to nano-coated part, that's a DC.
Yes.
If you go to the matter part, if you have a perfect digital, very high quality, you know, voltmeters, it can show you that you have an AC in there too.
Yes.
As you make that transfer, huh?
And that's because of the fluctuations in the fields.
Yes. So these kind of things, you know, Rick, you know, we're thinking to animate that people, you know, they watch it and it will simply explain, and they don't have this point of nano coating. They will understand the next step, what they did. What they are doing, you know, they just separation. They creating the separation. What GANs? They are more separated now. You can.
That's right. Yeah. Once we have that first animation with the matter level and the nano coating showing the expansion there, then we can easily add in the next level, which is the GANs that Armin's
the GANs
showing there, which is even more open. It has more degrees of freedom.
Here are attached. See these guys, these things, they are still attached to the matter. But in a GAN state, they are free to manifest itself, that you can see that smallest dot in the water. It has to have both gravitational and magnetical, that the balance you see as it appears, as it manifests. That's all. Then you understand, now you have a neutron in your hand, so you have billions of it. Now you see, you vibrated an electron and you collected certain energy. Now think how to vibrate a neutron. to get
What do you think of Jay's comment that he says is it a bit like the way hair would attract and hold static because the nano coating is so fine or microscopic?
correct. It's a atomic structure.
It's more like holding static than holding electrons. It's not matter level necessarily. It's the plasma that's
the plasma. Now each itself, they 360 degrees, they radiate energy. They receive to sustain in this environment as a atomic structure of the copper or any other element. It need to have both fields, magnetic and gravitational. In a balance, you see it as a entity. It's so small, but still it's an entity. It can hold in this environment and have a mass.
Breaker, this is Denny. When you place, and when you've finished with your steam coating of your nano-coated copper plate and you take your multimeter and you put it on one portion of the nano-coated plate, and I think it's the other probe, I think it's the negative on the grid that sits down below the zinc grid that you have in your nano-coating kit. What's happening there? What's that process all about?
I am so sorry. Can you repeat the, last 1 second, because I was off the line for a moment. Hello?
Can you hear me?
Yeah. Can you repeat that again, please?
Yes. When you're finishing your nano-coating process of your copper and you're putting your multimeter on the nano-coated copper and the grid, the wire grid, the mesh grid that you have below, what's happening there? Which pole do you put on the copper? Which one do you put on the grid?
No, you are directing the energy. If I put in my minus here and my minus here, my plus here, oh my God. Okay, what I do, I direct the energy from here to here, correct?
Correct.
Now everything is in line. From here to here. You like setting it up for the transfer of energy. Now you put the path where to go. This is the start. This is the beginning. This is the end. You pass the voltage. This all molecular structure, they already in line. That's all. Then you let it in your container for a few more days and you do one more time. It depends how hurry or how fast you need to create a nanomaterial. You can do it in 1 day, or you can do it in 3 days, or you can do it in 1 month. Until it's in a container, the process is still going. A minute you take out, you wash the caustic on it, that's it. It stops.
So I've had some nano-coated copper sitting in a box for over a year.
Doesn't matter that. Still, what it is, it's still the process is going. More longer you put, more slower the process goes.
And do I need to?
Because these layers now the interaction, out of this interaction, because you have a condition of, you know, NaOH, still this process is going, still they are growing, but the process is very, very slow.
And also some of the copper oxide will be turning back into copper and going back into the matter level state at the same time as other parts are being turned back into the copper oxide, because there's an exchange going on inside that that structure, and there's travel of the entities up and down through the structure to create the new layers and so on.
If you have a very thin, you know, copper foil, and you just, you know, nano coat, and in like 5 minutes you put it in a cold water, you create a bluish color on your copper, not black. This blue are GANs and nano-coated GANs. They are like GANs, but in that moment of separation, you freeze it. They are attached to the matter still.
Or if you had a little bit of, say, vinegar or some sort of acid that was just a light coating on the surface, that would start immediately converting back into copper, some of the copper oxide, and it would start, you know, and we have acid on our fingers, we have acid in the environment, in the rain, and the all kinds of acids that would tend to immediately be at that surface if it wasn't protected.
Yeah. And the minute it touches this, you know, different condition, because you took it out from the salt water and now in a cold water, you know, it's totally different environment. The minute that you see the blue, perfect, velvety, nano-coated blue color. This is GANs, which they are released, and they are like, it's a temperature. What is temperature? What is cold? You're taking the energy. Hot, you're putting the energy in. Cold, you're taking the energy out. So in that second, it's freezed. It's beautiful. You can try it. You can create, you know, your copper GANs with it.
Armand, can I show you photo, because probably I got exactly this type of nano coating material on the photography on my coils. I will ask you. I would like to ask you. This is the same thing or not?
Yep, sure. Go ahead, Thomas.
All right.
I'd like to get back to Mark soon too with his thing here, because I'm starting to get on here into almost for 2.5 hours or so.
Okay, but I need to share screen. A second.
Oh.
All right. Thank you. All right. Okay. That's a close view. I mean, the room gets warm color, so the light, the reflection is quite warm, but original color was really, really beautiful bluish. And all this material, top of the coil, that's actually GANs. See in a closer view. It's not the most bigger resolution, but As you probably see perfectly all the.
It's a good clear picture. Thank you for providing a clear picture so we can see what you're talking about. Although, like you say, there might be some changes in the color that don't show up properly.
Exactly. This is something like this.
Now these coils have been washed well from the caustic and so on, or did you leave some caustic deliberately on them to help it along?
I was wash the coils in the hot water for 30 minutes, something like that.
Okay. Yeah.
But do not touch them. But absolutely do not touch them. Just dip it in a hot water. Don't touch any box, anything like that inside.
Okay. So what's the question or the aspect here is the color that we were talking about?
Yeah, this is the Ganset. That's what Armand says. This is the Ganset of the coil. All this whitish material, kind of bluish whitish material.
Is that what you mean, Armand, when you were talking about that?
No, it's a blue color, like this kind of blue. Lots of like a sky blue. When you do your GANs,
yeah, they got sort of kind of blue reflection, but
GANs of copper. When you do your GANs of copper, this is the color you see, huh?
Okay, yeah, exactly, yeah.
This is the same color. It's all over, but that's not the point. You know, I just explained that this is Mr. Keshe's technique. This, you know, and explained, and it's now you understand it's differently. So. For a moment, I just want to explain that. That's all. Anyway, now it's beautiful. That's what you made. But now, did you put some CH3 in it?
Little bit, yes, little bit.
No, inner coil and outer coil.
After then, yes.
Put CH3 in the middle and CO2 and copper oxide maybe outside.
Okay, thank you, sir. I will do. Okay. I also, because I was thinking about conjunction CH3 with the GANs of sugar, which is extra, let's say, carbon, something like that. Also too.
Right.
Armin, maybe you could answer a question that came up earlier from Jay about, and it comes from Dimitri regarding nanocoating, and how does the nanocoating of alloys differ from the nanocoating of elemental metals? I know you have some experience with that, with copper and brass in particular, say reactors and so on, that you've been nanocoating in the past. And how does well, brass might be a good example. How does the nanocoating of brass differ from the nanocoating of copper, let's say?
There is no difference between nanocoating part. It's a difference between what kind of material you are using and what for you are using.
And maybe some of the alloys might be a little more difficult to nanocoat in terms of you might need more heat or more stronger caustic.
What do you want to create? Because with the copper you have everything. You have plasma. Just understand why we're doing nanocoating. We're opening it up, the plasma. Meaning, when the matter, the plasma is inside, because this matter came from plasma field to our Earth and materialized itself as a copper. This copper that you hold, came from the field. So now, when you nanocoat, you're opening it up, this field, for interaction to its environment. Because, Rick, we have to create this Animation, please.
Here we go again, Ermin. Those little balls. This is nice and neat and tidy, though. I'm hoping that this will be the one that'll inspire the animator.
I hope you understand.
Yeah.
It's anyway, that's between me and Rick. Here, this is your matter. Your molecular structure, it's all tied up each other.
Good thing you don't have to do 30,000 layers each time, Armin. You'd have one sore arm.
It's okay. See, in animation, it's easy. We can create it. We can show it. That's how it looks like. This, they don't interact. They interact, but they are so close, tied up. If I hug you, you cannot do nothing. You cannot even move. But if I leave, you know, you can now interact. Now you can move your hands. You can shake it. You can do something. You can shout. But here, it's very tied up space, so you don't have much. You cannot much to do. Only you pass your energy to one each other, and that's all. But in a plasma state now, you have interaction. It's a space between 1 and 2, 1 and 3, 1 and 4. This all, they interact with each other. Now they are busy. Now they have more of space to interact. They like our plants, still attached to the earth. They absorb, they release, they move. But in a gas, now you don't have no connection. Because of each, they manifest into the atmosphere, onto the environment, and you can see it. So this is the process. This is the process what we have to learn, what we did. From the field, we have a matter. Now from the matter, we created a condition which we can release it. Now each of them, they release the field of this matter, of the condition which you created this matter. So they carry the field. Now you have a billions of it. Because in one container, how many atomic structure you can collect? Like neutrons, huh? The water in between, it's a gap. So why we cannot have the energy of neutron? We managed to vibrate the electrons to collect the energy in a matter state. I'm talking about the field state. Now, each of them, they release the field, they absorb the field, which you hold in a container or in a bag or in a jar. They are free. You free them. Each they hold the structure. Every day, every morning, you can wake up and see. But in time, if you use the water, let's say this is your jar, every time you take this water, they will carry exactly the fields of this GANs. But in time, they will lose some of their fields. because the water that you took out and you drink it or just, watered your plants, they took the fields from it. Now, if you put the same GANs into the newest GANs, they still regain their fields back. So you can always add more. Just understand, this is the sun, and the field comes out from here. It's very strong. Until it goes to the end of the universe, it gets weaker. Because this layer of its path is going to lose some until it gets to the end of the solar system. Then when it's very light hydrogen, most of it comes back again.
May I contribute with a little animation?
I will love to.
It's an inside up. I have to share my screen.
Okay. Can you go ahead? I think you can. No?
I need to share my screen, so please, Armen is sharing his screen right now. I cannot. Okay. Stop the screen sharing so I can.
Yeah, there. I took over and then I stopped. Go ahead.
Yes, thank you. So what you see here, they are such a ball magnets. Let's say they are representing the atoms in the molecular structure of the copper before to do the nano coating. So they are very tight, so almost nothing of that size can fit into. But if you release that, some of the fields, you see they are arranging another way, and so you get some gaps inside where you can fit some other things. So again, so this is in a compact structure, and this would be in a kind of nanostructure. Just you will have not only copper here, but you will have alternating copper, oxygen, and whatever. But it will create such kind of gaps. It's the same stuff inside, just the relation between them has changed. So it's good to play with such a things sometimes.
Good point. Thanks, Shandor.
Yeah. And by the way, Armen, while you are here, and it's not going too late, have you ever tried to make GANs by the fields of GANs? So at Rome conference, Mr. Keshe repeated that he inspired us so many times to produce GANs by the fields of GANs, not by the fields of nano-coated plates, but by the fields of GANs. And he gave such kind of drawing. So we use a nano-coated plastic tank, so to have a plasmatic environment inside. By the way, I used to nano-coat my plastic boxes even for making GANs in usual way, just by heat treating with hot caustic. And then to place two containers with two different gases inside, and to fill the rest with salt water. So here is salt water. And the trick is to connect them together with some nano-coated copper wires and through a plasma capacitor, which you learn how to make it from the Maggraf blueprint. So in this case, we can play with the qualities of the gases which we use here, because they create their own fields and they also interact. So what happens if we use, for instance, a CH3 GANs? and CH4 gas. What's the difference between? Don't we get the field strength which would pull the fields of hydrogen?
Good point, Shandor. Yeah, good one.
Or how about to use not CO2 but copper oxide gas and zinc oxide gas? So what's the difference of field strength in between? Only I'm trying to inspire. I hope in time I will be able to make the experiment. But those of you who have different kind of gases produced, and you have some nano-coated copper wires ready-made and some plasma capacitors, you can try it straight away, even today or tomorrow.
Thank you, Shandor. That was good.
May I repeat my question about the nanocoating? Now we got the process beautifully right by Armin. But my thought was still, when you pour on the hot water and it creates the first layers, would it be beneficial to keep an elevated temperature for some time in order to keep the process going on, or is it better that it cools off and go more slowly?
Just understand.
What are you creating, first of all? You have to, what exactly do you want to create?
No, first of all, just understand, in this moment when the reaction is starting, correct? In that moment, you cannot create you can never create that high energy, because it's a very high heat it creates. You know, sometimes when you put a plastic, different plastic, melts because the heat is very high. Yes, you can create that heat, but you don't need. In that moment, first layer, first two layers, when they established, rest it's ongoing. Again, until you don't change the condition.
That's a good point about, they call it a seed layer, and those first layers are the seeds for the rest of the crystal growth, essentially.
When you do your agriculture, you put one seed and another seed and another seed, correct? You don't put one seed and on top another seed or another seed. You already create that.
Yes.
In that's the process. When you with the torch, you just fire it, correct? It's you creating that heat again. Cooling down, heating up, cooling down, heating up, you create that layer.
Yes.
It's the same process.
Yeah. For example, in some scientific processes, they'll have a chamber that's got a certain temperature that they'll keep it at, like maybe 600 degrees Celsius, and have an oxygen environment or air over that in that enclosed space. So it's and they might have that temperature for 2, 3, 4 hours, or even for several days in some experiments. And but the introduction of oxygen in that environment creates the layering, continues to create the nano layers until you stop, basically, and that's what the caustic environment will do. So yeah, your question about the heat will make the process go faster, essentially, and that's what Armin is indicating here with his cold water treatment, is a stopping, whereas the heat, especially in the initial process with the caustic, and sometimes there's aluminum in there and other things it's all bubbling and hot, but it's much hotter than the 100 degrees Celsius of the boiling water. You're actually introducing at the surface level of the copper, for example. It's just, you know, very strong processes are ripping and tearing at the atoms and causing them to tear off the surface and combine with oxygen and so on. It's quite a violent exercise going on there.
I'd recommend all the listeners to go back to the first Keshe Plasma Reactor Group meeting of this year, of January 3rd, 2017, and go to the 2 hours and 42 minutes and listen from there till the end, when Mr. Keshe entered into the meeting, and he explained a lot about the differences between different methods of coatings.
Thank you. That's exactly the question I had earlier, Shandor, and I was going to suggest that that would be good for Jay and others that have some of these basic ideas, you know, what's going on in the nanolayers and so on. Just listen to Mr. Keshe. He's done this several, well, probably several dozen times through the last few years, but specific times when he starts to lay out, similar to what Armin has shown here with the nanolayers and so on, and that can be very useful. And could you say that again, Shandor, when that it was January 3rd?
Keshe Plasma Reactor Group meeting of January 3rd, 2017, 2 hours and 42 minutes.
Perfect. Thank you very much. That's a good hint for people to review on it. Okay, we've got some background sounds happening here. Let me find out whose microphone's open. I can't find my screen right now. There we are. Armin, I'm going to mute you, Armin.
Somebody woke up his family in the night.
Armin, I can't mute you there. He's muted now. Yeah, I guess we have to talk softer. Anyway, that was a good review. Now, that's good, and that'll help also the animation team to clarify some of those points, and gives them also the link to Mr. Keshe's explanation as well. So that'll help tie up that, and hopefully we'll get some animations going on the nano-coating process, which would be really cool. Now I'd like to move along to Mark here, who's been patiently waiting for quite a while, and hopefully still hanging in there. I didn't mean to launch into all this stuff, but things go on here, Mark, and if you don't get your elbows in, you know what happens. Are you still there?
You know me, I'm still here.
Hey, always. Thank you for being so reliable. Do you have something you want to show there at this point, or how are you feeling?
If you want to stay up, you want to keep talking, that's fine. I got to work, so I got to work in the morning. I got a lot of work, and I'm dead tired, but... Oh,
okay, yeah. Well, if you have something important you want to show, and it won't take too much of your time and so on, then it'd be a good time to do that.
Time, you know what, I'll say this. I just want to make a testimony right now. You know, everybody knows I work, I got to get up and I got to go to work every day because I'm poor. And it doesn't matter because I have to work. I'm a working person. I work in Detroit. But you know what? I use the Keshe products, and I use the stuff that I have. And you know what? I am not tired at all. It's 3 o'clock or quarter to 4 in the morning, and if you would have, a young man that would have looked at me today and thought, man, did you do all that work by yourself today? Yes, I did all this work today by myself. I'm still up at 4 o'clock in the morning, and I will sleep for about 4 or 5 hours, and I'll go back to do the exact same thing I did today, and I feel the same way, and I want to say thank you. Thank you very much, Mr. Keshe, because I feel wonderful. I'm 57 years old. I should not feel this way. I should be tired and sleepy and cranky, and ornery and all that stuff, right?
Well, you might get to that point in 5 more years like me.
No, you know what? You know what? I was to that point, you know, maybe 5 years ago before this.
Right, yeah. I was more
down. You know how life beats us down and says,
absolutely. And then we have to pull ourselves up and you know, figure, okay, I have to stop whatever it was I was doing that was pulling myself down, or get away from the environment, and so on and so forth. So yep, stuff happens, and okay.
And the funny thing is, you're still in the same environment, and you still got to wake up in the same place, and still feel the same way, and still feel happy about it.
Yeah, that's the thing. The thing we can change is our approach and our mood about the situation, because we don't have to be bound to certain emotions.
And ugly and take a negative attitude towards life anymore. We have a better choice. You know, up to a couple of years ago, it didn't feel like I had a choice. I just had to do the things I had to do, and I wanted to get out.
Mm-hmm. Mm-hmm.
And now I feel like I want to get in instead of get out.
Yeah, right. Everything's inside out. Yeah.
Does that make sense to anybody?
Well, it makes sense to me. I don't care if it didn't make sense to everyone else. It's
so anyway. Okay. I'll go fast. I'll try to keep it short and sweet. You know, because I got so many projects and experiments going on at this point. It's really
all
hard.
right. Well, give us some of your creme of the creme de la creme, as they say.
Well,
right?
the creme of the creme. Well, you know, because I want to start with basic stuff. I'm always a bottom line basic person, and you know this month,
is good. This is what we need. Yep. So go ahead there. So do your thing.
Well, this, you know, you're looking right now. I don't know if you want to pin it, but you know, this is I'm a production guy, production line, and this is the production this month. You know, I did the Epsom salt, I did the Himalayan salt. This month, I did the 12 plasma salts, like Armin suggested. So this Gantz run here that you're looking at right now is the 12 plasma salts with a little bit. The 12 plasma salts are really concentrated. So you've got to be careful. Like he said, you don't need a lot. And I can back up everything he said, you know, through the nano coating. And I had to contact Armin because of the, I put a little bit too much of the salt in it, and it turned all my coils green because of the copper and the green and the salt. Just, whoa, it was way too much. And he said, just back it off a little bit. You got to learn how to work with the salts, and work with the salts in the caustic process of nano coating your coils. And well, this just happened to be coils that I needed to make Armin connections with, and they turned all green, and I freaked out.
So the idea is that the salts accumulate. If you put in all these different kinds of salts, the total salt content will increase, right?
Yes, I mean it'll multiply in the thousands. So I mean I might have in a 2-gallon solution, I only use like 10 grams in a 2-gallon solution. 10 grams. I thought, wow, that's not very much, you know, in 2 gallons. Well, the way I do, you know, the way I do my process, you know, in the roasting pan at 160 to 180 degrees, woo, it turned them coils greener than green. I thought, uh-oh, I'm in trouble now. I gotta get a hold of Armin. He just said, just back it down. And I had to change the solution a little bit. And I backed it up to like about 3 grams to the 2 gallons. And then it made a really nice coating on the connection. So yeah, it's everything is, there's no absolute to any of this. It's all I don't want to say it's a guessing, but you know, you got to hone your process. And you know, like I said, if you don't look at things and you don't pay attention to things, things will change on you, and you have to have you should document and watch everything that's going on. That's all I'm saying. But I'm trying to go as fast as possible here. But what you're looking at right now, I'm looking at Rick's face. Do you want to pin the containers, Rick? There you go. Let me just lower that.
Thought I did that once or twice, but okay. I think we got it now.
Okay, looks good. My question on this one is, has anybody taken readings on their GANS production? Like, or, you know, put the meter on the GANS?
You're talking about pH readings, right?
No, meter readings. Millimeter, you know, millivolts.
Oh, you mean the voltmeter readings on the GANS by sticking the probe right into the GANS?
No, actually sticking the probe, like, you know, like I have them connected now with a little LED, but, you know, like on this side there's nothing connected, but the rod goes through, you know what I'm saying? So I just put my connectors on each side, so I'm getting a reading off of every container. So I started taking a reading.
I'm getting a reading even from distilled water.
Pardon me?
I'm getting a reading of some voltage between 2 points of the surface of distilled water.
Mm-hmm. Yeah, and we've seen different voltages and so on in back 3 years ago or something when they were experimenting with different GANSes in small containers, like but beside each other in cells, and you'd have all this cell arrangement, and they were taking voltage checks in between the cells and having different voltages. But yeah, okay, so what are you finding here between them? That's interesting. That's the part that we should be paying attention to.
Well, week 2, well, I started this on 3/28. So every week I take pH readings, and now I started taking the millivolt readings, and on all the different each week it's different. Like the CH3, it started out at on the millivolts it was 33.8, and this week it went down to 16.8. Does that make sense?
Yeah, sure.
Okay, so the next one here, which would be my, you know, I don't know. Can you read all the ingredients that are in the containers? Do I have to read them all?
No, it's very clear. Very good shot. Excellent picture. Thank you. Okay,
so in this container here, I should say this one here, the pH was 7.9. So in this one here, I was getting a millivolt reading, and the first millivolt reading was a 0.475. This week it jumped up to a 0.650, which would be more than a half a volt. This was a little under a volt. Now it's over a half a volt.
Can you tell me where each probe of the voltmeter would be located when you make the test?
Yep. So when I make the test, I put one of the probes here. Can you see? One of the probes on the outside here, and then the other probe, so I get a cross reading on this side. You know what I'm saying? So
those are wires there, or okay? Well, so one side's that's the rod. Okay, so that's the plate in the back and the plate in the front, basically both plates. So yes. You have a yep. Well, so that's normal to have a voltage. In fact, yeah, you can have salt water or caustic, and it will create a voltage between the plates. Yeah.
Okay, so so each different container has different readings on it.
Right.
Some more,
Yep.
some less.
Yep.
So that's how I'm taking the reading is off the, I have
Okay.
nano coated,
Got it.
all the nano coating on the back, all the non-nano coated in the front.
Okay. Thank you. I understand now. That's great.
So, so I just keep taking readings, different readings from each one of them, pH reading and millivolt reading. So I don't know if anybody's ever checked the millivolts on each container, but that's what I'm starting to do with this one, whether it matters or not. So we'll just keep moving on, unless anybody has any questions about that.
Can I add something? I'm Theo. Actually, I used to read millivolts by the beginning of the reactor, and it's higher. And after it decreased the voltage after the plasma interaction, maybe it's somehow get a equilibrium state.
Well, yeah. What happens too is you get a buildup of GANs or oxidation on the plates, and then it no longer conducts the way it was initially.
Correct.
That's exactly. That's what I had thought too. And when you put the meter on it, it seems like it, like when we discharge the nano-coated plates. If you leave that your meter on it a while, it seems like it discharges everything.
Well, that's right. That's the whole idea between hooking the plates together with a nano-coated wire or some other thing like a diode, an LED, or a little fan. So it uses up that power and causes a better condition for the GANs and so on. Instead of injecting that energy into the solution, that 0.6 volts or whatever, that's quite a high voltage. Instead, it would be drawn down by a little fan or some other resistance, and then inside you would have more of a plasmatic environment rather than the voltage difference to create the GANs inside. I think that would be part of the idea there.
The LEDs, the LEDs I use do have a resistor on it.
Oh, right. You do have LEDs there already, but when you do the voltage test, then basically you're just drawing down any residual charge that's is on the plates and so on.
So I try to make sure that I don't take the reading off the resistor. I try to take it off the plates itself.
Mm-hmm. Okay. Yep.
Okay. So, and then you're just looking in the corner there. That was, I know this was held your attention, was the, this time I did the, so I thought I should try this one here. Here's the two that we saw the last time, the iron ore and the copper ore. Okay, so what I did.
Oh, I thought it was some kind of bat or something, some sort of organic thing. I couldn't recall. What the heck is this? It's some sort of rat that's dove in and. Okay, yeah. So that was your iron ore, and what's the other thing in there again?
Yes, and copper ore.
Oh, right. Okay.
So the first time I made it, I have, let's see, where is it? Here it is. Remember the first time I made it?
It didn't do too much, right? The first time?
No, it didn't do too much. So let's see if it's here. No, that's silver. Anyway, it didn't do too much. But this time, so with these two stones, what I did was I put them in the hot caustic solution in the roasting pan, because I thought, well, they were already together. You know what I'm saying? So last time they were just two of them. So now, and they didn't make much. So I thought, well, okay, they're happy together now. So what I did was I put them to make them the negative, or the the nano coated. So what I did was I dropped both of these in a in the hot caustic solution 3 times, and did my caustic wash on them.
Beautiful. So
so I thought, well, okay, that'll be my negative charge. So then I put here on the other side. Oop. So just to have fun, I got a piece of bismuth.
Okay.
And a piece of fool's gold, Pyrex.
Pyrite.
Yes. I just thought, well, to give them a positive. I thought that these could be the
pyrite's interesting. It's actually iron pyrite, right? That's what it's fool's gold is. Yeah.
Yes.
So, first of all, did it produce anything? Did you add those last 2 things later, or did it produce anything before you added them? I was wondering.
Well, I don't know, because I started the whole thing.
You did it all together. Oh, okay. I wanted to see. I was hoping that just the copper and the iron by themselves. But go ahead. These might not make that much difference in this case. But anyway, go ahead. Yeah.
I guess I don't really see the difference in it. You know what I'm saying? Because everything on, it's these two haven't changed at all. And all they're doing is just letting the whatever is coming off of the iron ores is just gathering on those two.
So where's the GANs coming from? Is it coming from the copper or from the iron?
I believe it's coming from the copper.
It looks like it. It's the right color for copper and so on.
I think the copper's the most giving of it all. There is, because this is pure iron. There should be a little bit of red in there, don't you think?
You would think, but it's because probably the copper is giving first, and it'll just keep giving instead of the iron, like.
Well, I guess that,
because that's the way these reactions work. You can have a substitute, put in a different item from the atomic elements, and that way it'll be a substitute or a sacrificial anode or cathode or whatever. They do that in boats, so your aluminum boat doesn't corrode. You put a magnesium or zinc anode, big chunky thing on the back of the boat, so your motor doesn't disintegrate. Go ahead, sorry.
Because it'll track that, what you're talking about, attracts all the static electricity that's in the water.
Yeah, it's sort of static, but it's called a galvanic reaction. It's salt water and 2 dissimilar metals. Then that means you automatically have a electrical circuit, and that circuit will, because of the potential, it ends up eating away at one of the substances and creating an oxide and essentially pitting the surface, and the other surface will be kept in its elemental state due to the sacrificial part of it, the sacrificial element that takes the place of the other one, normally corroding. So your aluminum outboard motor doesn't corrode in this salt the way it normally would, because you have this anode that's attached to it. It could be zinc or magnesium as an example. Do the same thing in hot water tanks, where you have a magnesium or zinc anode inside that keeps the iron from corroding and rusting and causing a lot of rust inside the water tank, which is very similar to what we're looking at here.
So maybe they should put what you're looking at to to the left of the bubbler there? The little white thing that's dripping.
A little closer to the microphone there, Mark. Hard to hear you.
Sorry. So do you see the little white crustation that's to the left of the bubbler?
Can you center the camera a little better? We see it, the whole container kind of on the whole left side of the picture, and we can't see it quite properly.
Which way would you want to go?
To your left. Are we looking at the bubbler and the small container?
What I want you to just, this is just the end, but this is just funny. But if we could do this, but see this here?
Oh, okay. I thought that was a reflection or something. That's a something coming out. What's going on there?
The container is split up in the, it must be a pressure point up in there.
Yeah.
And for some reason it had it made a crack of itself, because after I'm done with these, this is, I don't know how many runs now we've had of this one, these containers, but it self-healed itself.
Yeah.
It used to rip, you know what I'm saying? But now it, from the inside out, it healed itself.
The salt has healed itself. The salt has healed the wound. Yeah. Well, that's very much the way it works in our human body. When you think about it, when you cut yourself and the blood coagulates at the surface of the interface between the atmosphere and the skin in this case is the container itself. And when that internal GANS environment gets exposed to the atmosphere, it does different things. In this case, it's well, the GANS and salt or whatever it is. It's coagulated and formed.
Absolutely,
formed a little stopper there. That's great.
Well, because I have it in 2 different spots.
Yeah.
So
I mean, this is an example, for example, that maybe this material would be good. This concoction would be good in a radiator of a motor vehicle, because if it developed a leak, it would be self-sealing, for example. You know, some sort of situation like that. Okay, go ahead.
Just another fun observation, but you know, after that, but anyway, so this is kind of what I was, you know, that's basic stuff, and you know how.
Well, actually, one more point about this that could actually be important now that you brought this up, and it goes back to was it Shandor? Weren't you talking about this earlier about the salt, the salt of the salt, or what do you call it? It's a French word.
The
fleur de salt, salt flower.
Fleur de salt. Fleur de sel. And that is, could you explain about that again? And then I think Mark could get something out of it. What if this salt, this material we're seeing is fleur de sel or fleur de la GANS?
I can't start my video. Yes, I know why. Because my video software is working. Just a second. So this bottle, for instance, was just touching the side of the container. It was here. It was touching this place. So you see, this salt comes off. Usually, if you have a salt solution, whether you make GANS or not, some salt will creep out of a container which has a salt solution in it. And you see, it walked through the bottle and it started to grow and to get higher on this other side as well. So this is like the salt makes a flower. French say fleur de sel, the flowers of the salt. When salt is obtained from the ocean or from the sea, they used to collect the seawater and they put in huge trays and let evaporating. You have to know that different kinds of salts which are dissolved in the sea at a certain temperature, they have an order. So first is crystallized one kind of salt and the other kind, so they can separate sodium chloride, potassium, magnesium salts, and so on. And what creeps over the edges, this is harvested as the purest salt, and this is the highest price, the highest value. You can make it. You just put any kind of rough salt into a plastic container or plastic tray. You add a little water to it, and you just leave it over several weeks, and you will see the salt starts to grow out. And that which you harvest from the edges, that's a recrystallized, purified salt.
What if we put little micro holes in the container, like Mark has there? Mark had a pinhole leak, and it produced all this fleur de sal there, and perhaps you could deliberately put little holes around the container and harvest the best of the best GAN salt out of it.
You can try whatever new methods.
GAN salt.
If you put in plastic trays salt with water, earlier or later you will have the salt growing out.
Mm-hmm.
It's a habit of the salt. I like to
maybe that's
what's their opinion about what's the force which makes the salt to creep, to go step by step.
Levity. I think salt has levity. It wants to be free. Its main thing in its main objective is to get out of the situation it's in and spread. And it'll turn into a vapor and then a solid, and do whatever it can to exit the situation.
Yeah, it's beautiful why Mark shows. On the bottom you see beautiful salt crystals, and on the walls it's these little crystals which are creeping.
Yeah, and if you leave it over a period of time, the crystals will grow on top of themselves, and they'll try to creep and grow and sometimes form structures that are, like inches or centimeters high. And it always seems to want to go more, up, it seems, but up and out at least. Although I see a lot of yours around the bottom of the container as well.
Well, as you can see, it definitely grows up and out.
Yes, and it's interesting, it does that on different surfaces, be it of plastic or glass or wood or metal, does not matter.
Yep, so this is the thing, is that the crystals seem like a tree. A tree is similar. A tree craves levity. It wants to go up. I mean, a tree will levitate several tons of weight over its lifetime, over the surface of the earth. Think about it. And yet, crystal is similar. That leading edge of that crystal is wanting to go upward. It's not like going down into gravity. It's going exactly against gravity. It's full of levity. That's why we need to work with crystals more, I think. Levity is the cure to gravity, of course.
I haven't seen the diamond or the pyramid structure in the bottom yet. I've seen like down here in the corner, you can see like squares but nothing building high. Somebody said that they showed actual pyramids of salt crystals, and I haven't seen that yet.
Yeah, yes, it happens that too. Now what happens if you have a pure sodium chloride that usually makes cubic crystals? It makes small cubes. But if you have it doped, it means infected with a little other elements, small quantities, it changes the properties of how it crystallizes.
Yeah, that's a really good point. Really good point.
If you add a doping material inside, just a small quantity changes. once I had several plastic trays, which I made gains in them. I washed them, but still I emptied them, and still they had some salt water when I put them inside each other, one inside the other. And after several weeks, I just observed that they had such a beautiful small crystals like tiny stars. I don't know if I can find quickly those pictures. These are from 2012, several years ago.
I have some pictures that that was where I was going to go next, was the frozen pictures that if you want to wait to see what, can you find them, Sandor?
I'm trying to find them.
No, we're still trying to hook up with some pictures that Shander is looking for, I guess. Is that right, Shander? You're still looking for something there?
Yes, I'm still looking. It will take about 3-5 minutes now. So
oh, okay. That'll
no
be
hurry.
too much dead air time, I guess. So we better...
Don't wait for me. I will shout and we'll be ready.
Better fill in here. Let's see what we have for more questions here. I think we've covered most of it, though. There was somebody I'm missing here. Plasma head. Rick, may I show something I'm trying with nano coating? And here's Mark, back with Mark's screen here. Okay. We have some of Mark's remarkable frozen concoctions. Mark's remarkable freezings. What do we have here, Mark? This is a coil, it looks like.
All right, it's not a coil, it's the capacitor.
All right. Mm-hmm.
So this is the these are the two little prototype capacitors that I made that we seen on the did I show them? Did I show these two that were prototypes like this?
I think so, yes. I think we discussed this last week, wasn't it?
I think so. So anyway, the one you're looking at right now is this one was the more stronger of the two. I made two of them, and I have pictures and everything, but this one actually was pulling more than a half a volt. This one was 600 and it started at 650, but it dropped down to about 610 in volt, millivolts. So, but the interesting thing here is what you're looking at is, let me see, annotate. This and this. Can you see that? Or can you see I should make it like this. Do you see the green ring or the green lines?
We can see the green lines. I'm not quite sure what you're indicating other than you can see the you're laminating. You're going with this. We see these different layers that you're indicating, right? These different lines.
Yes, and what it did was, do you see my cursor or my little?
Yeah.
Okay, what it did was it made these lines of energy around the top of it. And let's just go forward here. Why does it want to go forward?
Think you have to get out of annotate maybe, or?
How do you get out of it? Oh, I should. No, it's like this, right? There we go. Oh, should I erase that stuff? But
Sure.
anyway, I'll erase it. I'm just learning it. This is my first time. So, how do you erase it?
Oops. Oh, no. Did you annotate with the Zoom or with your program? Let me try to clear. I'm not sure if clear will work. I can't clear. Let me see if I can erase.
Yeah, Mark, you annotated with Zoom, so you'll have to clear it with Zoom.
Okay. Thanks, John.
Yeah, we went through this on Monday. If he annotates with this program, the lines are like a 1/4 inch wide.
Oh, okay. Thank you for clarifying. So you have to go back, what, into annotate and then clear on the right side? Ah, yes. There you go. Perfect. Thanks.
So I better not draw yet. I'll just go through some of the pictures, and then we can kind of, if you want me to go back, I can do that. So this is just the capacitor that you're looking at. So let me try to get to it. Here's another picture of the field. See the layers of fields that it made on the top, and it goes all the way through, almost like an echo. And I don't know if you can get a little bit, we can get a little bit closer. Can you see that?
Yes, definitely. Mm-hmm.
So I don't know how air makes these perfect separations, and they're almost perfect. If my camera is not that good, but I mean, if you took these things here are almost perfect. You know what I'm saying? How did that make that field like that?
Well, one way I would have to get clarified whether it's happening or not is whether the refrigerator is cycling on and off and creating colder and warmer environments inside the freezer itself. Because some refrigerators have a warming circuit that they actually do a warming cycle to defrost, you automatically defrost your fridge as it's freezing essentially. So it could be something, an artifact created by that. It freezes the air bubbles and then it thaws them and freezes and thaws them or something like that. So I'd want to clarify that. It'd be interesting to, you know, if somebody had a thing that shows the cycles of the refrigerator going on and off, or what would be best would be a sensitive temperature gauge, or you could put a thermometer inside and check it every minute or two or something like that, or every 5 minutes, say. I'm not sure. How long would this have been freezing to create this? Over a couple of days, or? Well,
actually, this part only created itself after 48 hours. In the beginning of it, it had this whole area here was all hollowed out like an egg. And I think I have pictures of it, but I'm not sure. I got a ton of pictures.
You mean it wasn't completely frozen in the middle, right?
No, it was like an egg that went like this.
Yeah.
Right,
Okay,
I
I
think we
remember
saw
I've seen that picture.
Yeah. Mm-hmm.
And there was stuff floating in the middle here. And it took, I mean, this center part took at least 48 hours to freeze.
Mm-hmm.
So in that process of 48 hours, these rings created itself.
Mm-hmm. But that was already frozen though on that top part, right?
Yes, it was definitely frozen on the top, but never in the middle.
So where the rings are though had already been frozen, you didn't see rings initially. They came kind of later then.
Yes, these rings.
Okay.
Came after.
Well, that's pretty fascinating.
Yes, and I don't know. Boy, if I could, let me see if I can do this. I don't know if I can do it or not. How do I get out of this? Anyway, I guess I can go fast, but if I see my each picture here of this, you'll see the consistency of the rings here throughout the pictures. It's like a hemisphere. Oh. This is the top, but you can't really see the. I mean, it created a vortex that went this way, but it's hard to see it. But the consistency of the rings anyway on this capacitor were just. I don't know how else air would make this in ice, to tell you the truth. I don't know any other way to describe it, I guess. I wish I could get to my...
Yeah, it's quite interesting, all right. Any comments on that? Anybody else see that sort of thing in their ice experiments?
Eva has a lot of pictures of this kind, and there's also these, there's both like a pearl, like a pearly, what do you call it, pearly chain of small bubbles that you see there that is illustrating the torus. And there's also some just like sphere-like texture that shows the central plasma. It has some like onion layers upon layers upon layers around the central plasma. But Eva has a lot of pictures if you are interested. Maybe you could get some from her. And many of the pictures has been made outside, not in the freezer, but she lives in Norway and it can get very cold there. So she just put it outside and let it freeze. And she observed the same, that the central is very long to freeze. Where the plasma, central plasma is, it freezes much slower than the rest of it.
Well, Eric, every picture I took, it seems like the top of the capacitor had more of the energy than anything else on this particular one. You know, because down below here, it's just, it seemed like the energy was very calm. The energy pulls from the bottom here, and it finds a nice central point. This would be like where you take your positive, you know, like the coil has a pickup point here and a pickup point here. That's where we curl them into one another. And this is just seems to be the harmonious point. And then as you look at the picture, it's, you know, that's the copper pickup point right there. But as you look at it, the energy keeps coming up to the top here, and it's in a spiral. As I look at it, it's definitely goes in a, I want to say, in a counterclockwise position. For me looking at it from here to there, it seems like it goes this way.
You know, Mark, I've actually seen this happen in salt when there was GANs at the bottom of the salt container, and I completely forgot about it. And the water evaporated, just leaving salt crystals behind. The salt crystals form themselves into, I would say, almost perfect squares. And I saw these striations that you're seeing, that you're showing on screen right now in the salt crystals. In fact, I have a picture of it up and I could share it on screen if you'd like.
Hi, Vivek. Yes. Anything.
Okay. So
Knowledge is great. Here, let me stop sharing.
let me share that. Okay.
Yeah. See, that's that. They grow like a pyramid.
Exactly. So do you see the striations on the salt crystal itself? I tried to zoom in, but I don't know if it zooms in.
Yes, it looks good. It's like almost like a pyramid.
Exactly. So I saw the same striations. This is copper oxide. And the interesting thing is I saw this on every single salt crystal in the container.
A pyramid with no capstone.
Exactly.
Yeah, but the idea, Mark, is the striations that he shows here. Like, if you see can you see my pointer, or
Yes.
maybe if I?
Yes,
then,
they go from side to side.
Well, there's one, another. There's this pyramid's built up in layers, like jumps and starts, rather than all smooth on each side. So it's forming in pulses, you might say, or in, it goes a certain length, and then there's steps. It's got steps in this pyramid.
Are they formed? Sorry.
Was that near anything that had like a cycle?
Yeah, some kind of cycle, a natural cycle is
Are they influenced by the moon?
Well, there's an idea. Maybe it's a gravitational effect of the moon, or maybe the night and day cycle. Mm-hmm.
Day and night cycles.
Quite possibly.
Much longer. I have a very similar photo, if I may share.
What was the time period, Vivek, of your crystals?
It was, I think, over a period of a week or 2 weeks, when I inadvertently allowed the water to just evaporate.
So it looked like about a couple of weeks of day and night cycles, for example. But it could also be tidal cycles, which would probably influence a crystal more than day and night even.
Yeah, and I live next to the sea, so that could have something to do with it.
Okay. Shandor, what do you got there? You got more of similar. That's a good example.
This is an abandoned box with many compartments where I left the water to evaporate. You see these interesting rings here on the nano-coated wires, and you see interesting crystalline structures which were formed around. Also, in other compartments, you can see perfect squares, which are square crystals, which are typical for sodium chloride. But also you can find that pyramid structure, or on another image. Just let me switch. Let me find the right one. Maybe that one, not that one. Not this one, another one. And it just shows the shape of the container which I used. I haven't opened so many windows, and so this is which I used for making some GANs with some nano-coated copper wires, with some chicken wire. And later I let it dry. And these are the little stars which I observed later in the boxes, which I put one into the other. Unfortunately, I had not very good light when I made the photo, and not the best camera. See those little stars. Just tiny, 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 and shining under the light. Unfortunately, I had no good light. It was in an evening or in the afternoon. So I saw similar pyramid shapes or star shapes at others also. So the way of crystallization depends on the doping or the other fields of the other elements which are mixed. In this case, it was some CO2 gas in it, and maybe those particles of gas which were left were the seeds of the crystallization for the salt. So basically, they are salt crystals, but they are influenced by the other fields which were nearby. Just a second, I have not too many open. And another interesting thing from the same, now this was later, this was in 2015, January, a couple of months later, just I left the leftover salt water near to the container, and you saw gas was created by the fields of the static reactors which are nearby. So, I mean, this was what I had to show now. Paul from Togo messaged that he sent you some on Zoom. By Zoom or by Skype? With Zoom it happens that it doesn't transfer directly the files. First it transfers it to the central server, and when the files arrive, then it pops up at the receiver that he receives some files. So if there are huge pictures, it may take some time according to Paul's speed of internet connection. Just one more picture. Here I made a nano coating back in 2014, July. I wanted to nano coat such a copper wires only on one half, and the other half was hanging out. So the other half remained not non-coated. And interesting, in the caustic, you see some GANs produced already.
Mm-hmm.
So I was looking for the salt crystals, and meanwhile I got so many other old photos.
Okay, let's go. We can whip back to Mark's setup here. He's got a nice picture that we can look at briefly. And are you still there, Mark, or you want to give her up for now?
Am I asleep? I'm almost asleep.
Yeah, me too.
Okay,
Maybe we should wrap things up pretty soon.
We should.
Here, but
I'll just show you two things, and then I'm out of here. These
okay.
are just the last two things I'm working on.
Yeah, Plasma Head wanted to show something too. I just remembered, so we'll try to get him in. Okay, go ahead.
Okay. Those are the capacitors.
Oh, nice. They look pretty cool.
They're ready to go get nano coated. So I think they're you can basically know, you know, the outside's copper. This tube is the brass. This tube is the aluminum. This tube is the zinc. Grab that. Maybe. Anyway, this the inner core is the that's the 14 gauge outer, and the 18 gauge outer, and the 12 gauge inner.
Quite a combo, quite a combo. It'll be interesting to see what happens when all that gets nano-coated and put together. It's like a combination battery, capacitor, galvanic response, intradimensional device, you know, you name it, it could be anything.
Well, we'll see what happens. You know, it's going to get nano-coated, it's going to get GANs, and, you know.
Just so don't point it at anybody. You could poke their eye out.
So here, this was the fun thing that I wanted to show.
Yeah, that's odd. What is it? What do you got going on there? It looks alive.
So this, I just kept thinking, you know, as far as our MagRav units, you know, if you had that, our middle coil that's supposed to sit down in it, it just seemed to me that it was just would make that whole field, everything a whole field. So I'm just thinking and thinking. So I just pulled the middle coil up a little bit above the basic coil, you know, and then on the top here, you see that's an egg.
It's okay, not only an egg, it's a levitating egg.
Well, it's an egg that is held in there by this tube, so that we've learned that if we had our central core unit that has to have our, say, CH3 or I don't know, it shouldn't start out the CO2 or the C8 or CuO inside, or lead or whatever. We want to make we want to have some way to make an outside gradients. I'm sorry, an outside gradient. So I thought we could just how could we change that gradients? How could we put something? This is just a three-way tube, a three-way T. In this way, you could inject maybe 2 milliliters of CH3 or a little bit of CuO, or on the outside here, your core is still the same, but now you created a gradient here with the tube on the outside here that connects it to your actual nano-coated copper white, your magrav wire. So if these three things were all nano-coated together, which they will be, this is just a prototype. This is just my thinking, and I know how to nano-coat everything. So if you could just imagine everything that gets nano-coated, and now you'll be able to. This is all static. This is all static, and this is all static. But guess what? Now I have an ability right here in this tube to change all this static ability, because you can add things here, because I just cut that tube off the top. So, if you wanted to hot glue it once you're done, but you'll be able to add a little bit of CH3, a little bit of CuO, or whatever it takes. You know what I'm saying? So each one of these units are now flexible enough to put what you need in your central core. This is very important. The central core is very important. But, if it wasn't connected to anything, then how could you get these three things to talk to one another? That's what I never understood. So here to here to here will now be nano-coated connected, so that once you bring in the energy from the middle to the outside, and then shoot it out, now you have an ability to have this central core interact with all these outside things. The egg. And the egg,
okay. Thank you.
I believe that the egg is an important aspect to this, is because we were using round balls, and a round ball is a perfect sphere. And once it finds its center point, then all the atoms, everything inside the center is happy. It'll just keep spinning around. It's happy. There's nothing that agitates it. There's nothing that gives or takes. With the egg, the agitation starts from the top and works itself down and back again, because there's no central point.
That's a good point, so to speak. Yeah, because I think it's got to do that. It's because we're in a Earth gravity kind of situation. Maybe if we're in space, the perfect sphere might work more perfectly. But in Earth condition, the egg seems like a more can create that condition of flow in our environment with gravity.
So I don't want to, it's late. It's very late, but this is my new idea. This is my new, once again, Mr. Keshe tries to teach us, please people, think more outside the box and not stand next to one another. We can all stand next to one another and make the exact same thing. But this, to do the same thing over and over again, you'll get the same results. So
right on, nice. It looks cute. It looks like it's alive already. Yep, nice.
So Eric and everybody else, we're trying to build fields. We're just experimenting. Everybody has a lot of input. Thomas with great illustrations and ideas. Me, I try to build things in order to give us physical ideas that we can actually look at. And so that's where we're at from here in Detroit. Thanks, everybody. I love everybody. It's late. And
thank you very much, Mark. Okay, I'm going to switch gears here, and that's excellent. Very good work. I'm going to switch gears and have a look at some of Paul's stuff he wanted to show here. He just sent me some pictures. Let's see if I can get that lined up. Paul, do you want to talk about this perhaps? We've got to get this lined up a bit better. There we go. We've got this structure, which I think you've described as having GANS tubes, and you've got a reactor at the top there, and this whole structure goes on top of your health chamber, is the way I understand it. I'll show a picture of the health chamber here. Let's get that. Okay, make it a bit smaller.
Hello,
Hi, Paul. Yeah.
Yeah, good morning.
There we go. So this is your health chamber.
Yeah.
And then you have
So,
you sent some pictures of GANs as well, I see.
Yeah. First of all, this we need to take a lot of time to achieve. I work on this now 7 months, but I finalized it 3 weeks ago, but still have some problem. The problem is the peel is very high. When people go inside, when I put on the motor, around the 8 minutes, 7 to 8 minutes, when I go up to 7 minutes, people start sleeping inside. So I suggest that the peel is very strong. And when I stop and ask them why you are sleeping inside, they say no, they don't need to go out. Here is very good for them. They need this unit. I say yes, but why you sleep inside? And still now nobody can give me explanation for why they are sleeping up to 7 minutes.
Right.
So
well,
what I have,
go ahead.
Yeah. So what I have managed to do, you see, the first one, the first picture you have shown. I make what I can call connection for every type of guns with the zinc guns in the pipe. First of all, when you see the pipe is 7 pipe. And the first pipe, I put zinc oxide guns and plasma liquid of zinc oxide. And then the second one, I put CO2 guns and plasma liquid of CO2. The third one is zinc oxide again. The fourth one is CH3.
Wait a minute, Paul. What pipes are you talking about? Are you talking about on your? Let me see, on your structure. Let me get the picture up here that I think you're talking about. This one here.
The top one. The first one you show.
Right. Okay. Let's get that back up here. So. Okay. There we go.
Maybe we could annotate it while Paul speaks, because it's very confusing to keep track of what is said.
Yes, right. That's why I need to get the picture up. I've got 8 pictures all over my screens here, Paul. You got to give me some warning when you send a bunch of pictures like this, because I have to get them all set up and try to get them arranged properly and so on, and they're not right now. So just send me a file next time before the workshop so I don't have to have them spread out all over my screens here and cause confusion and so on. Okay, carry.
Okay, so when you see the I take the pen. When you see, for example, this first pipe, I put zinc guns inside. And this one, I put CO2 inside. So this third one is again zinc oxide. This one is a CH3. This one again zinc oxide. This one CH3 is copper oxide. And this one again zinc oxide. So, and when you see the ball inside the ball where I put the motor, we get now guns of acetylene there. So this is for the top one. This is the way that I have managed to achieve the structure. So with this, we will get the field connection for emotion from zinc to CO2, and again Ca3 and zinc, and then copper and zinc, and then now all is connected to acid amino structure. And then the head of man is inside. So this is high emotional structure you are seeing there. So when, for example, I put on this motor and the people is in the bus, here 10 minutes only without hello. Hello. Okay. So I was saying that when I put only the first motor on in the top without putting the motor of the bus in the 10 minutes, the people can still sleeping inside with only this top one, with only this one. Sorry.
With only the top one, you say?
Yeah, with only this top one, 10 minutes people can start sleeping inside. Then, but when I on all these 5 reactor and we move the structure, then 7 minutes is maximum. Up to that, start sleeping inside.
Well, I guess.
So now what I am working on is I want to restructure the system, reduce the field strength of field. So I am thinking how, and I start again searching and reading what Mr. Keshe said to see how I can reduce this field strength. And if any one of you can give some advice about how to reduce this field strength, it will be very helpful for me.
Sorry, to achieve which field strength? I couldn't quite hear that, Paul.
You know, normally people should not sleep inside. But when they start sleeping, saying that it is perfect room for them to sleep, they don't need to sleep. I suppose that the field strength is too high that we have to reduce it.
Okay, right.
So I don't want people sleep inside.
Mm-hmm. Okay. So what are you proposing, or are you asking, or are you suggesting? What are you proposing here?
Yeah, I need some suggestions about how to reduce the field strength. But the funny thing is, they sleep, but they say that they are seeing everything.
They say what? They say
they say that they see everything inside, but they still sleeping inside.
Mm-hmm.
But as I understand it, you want to reduce the field strength inside this. But what about using some thinner tubes, not so big a diameter, so there's less GaNs in it?
Okay, I will try it and see.
That's a good suggestion. And also, I'm wondering, what is the effect of the aluminum itself, the metal all around? Is that going to be like is that going to affect people's, situation? What if it was made out of a wood product rather than the metal? It might have a better effect. But, I know you put a lot of work into that metal structure too, and it looks really good, so maybe try the smaller tube approach. It's not a bad idea. It makes sense.
What if there was if you did like a saltwater dump, to get some of that
right
energy.
And how would you attach that? See?
Maybe if you had some copper wire inside the tube.
Or maybe if that whole aluminum frame was grounded to the salt water dump.
Yeah, that might be a good. Yeah.
That might help.
Okay.
That might help. It's true. That's a really good point, Zane. I think that because does your health unit have a saltwater dump, or what do you call it, a ground or negative pole?
Yeah.
Does the rest of your unit have a saltwater dump, or is there do you use a saltwater container as part of your apparatus? Paul?
No, there is no water.
Okay, well, you could try that. That would be a good idea to ground the energies through a saltwater, maybe a couple of liters or even a 4-liter container of salt water with some kind of plasmatic connection to it that can drain off some of that energy fields.
Okay. So
May I
go ahead?
May I discuss another thing? Aluminium is a nerve poison, and everywhere we have to use this in relation to health issues. I'm a bit worried about aluminium because the fields of aluminium could maybe do some harm to the body. I don't think aluminium is a very nice substance to use in connection with health units. I know it's a very nice material to build something with because it's easy to drill holes and it doesn't weigh so much and
it's clean and so on.
Yeah, but you know, the chemtrails, they spray nano-aluminium, and the nano-aluminium does so much harm to people and to the environment. So
yeah, it's indicated in Alzheimer's and some other diseases as well.
Yeah, and what happens when we create all these fields and have aluminium near the fields and put people in there? What happens then? I don't know, but I just raised the question.
Mm-hmm. Yeah, it's not like it's off-gassing or giving off matter level stuff, but at the same time, it might be a concern. Go ahead.
I say I can change. This is not problem for me. I can change the structure in plastic or wood one. There is no problem for me.
Well, it's something to consider. That's two of us now that had considerations about the aluminum structure, and this has come up before with the fields. And if you think about plasmatic fields, they tend to be, if there's matter level stuff around, the plasmatic fields will tend to be absorbed by the matter level materiality. It doesn't allow the fields to do their thing. So, but in your case, it seems like the fields are too strong, so maybe you want to have the aluminum there. Maybe it would be even stronger without the aluminum is the thing. So, I'm not sure.
But if we are thinking of field strength, if you put no GaNs tubes there, how big will the field strength be? Less, I think. So in my
try and see.
Yeah, because if you have no tubes there, you will not have all those fields, right? So
well, in theory, except for some would say the pyramid structure would tend to have a certain field structure to it by itself, you know, but yeah. And the aluminum, but yeah, I know what you're saying. Yeah, if it didn't, it's the tubes that make this peculiar structure. I mean, it's quite dramatic to see it. It looks quite, you know, science fiction sort of thing, and it's pretty neat actually.
Maybe if you get some of the tubes used for air for aquariums, you know, fish ponds, that is very thin, maybe only 5 millimeters inside or 4 millimeters inside, then you have a lot of less GaNs.
Yeah, and close to the head, that might be all that's required or recommended, let's say. Good points. Does that give you something to go on there, Paul?
Yeah, you can go on. Thank you for your advice.
Did you want to show some of your GaNs things as well?
Yeah.
Okay, let me show a picture here. It shows the... Let's, if you could erase your annotate first, or... I'm not sure if I can do that. It won't let me... Oh, there we go. Okay. Okay, let's quickly buzz through your nano pictures. We have some big containers of GaNs here.
Yeah, so this is what we have prepared to face emerging situation. So with this big container, we have put 2 liters of pure GaNs inside of every container. Every container is 60 liters, and then we can harvest 50 to 57 liters of GaNs water every 2 days. And to face this emerging situation, we have in stock a lot of GaNs water. And when we harvest, all total we have around 300 liter every 2 days. So this is to show people how they can face emerging situation. So from here you can make your demand if there is some any situation you need groundwater to help some people. So here you see the pure gun we have put inside, and then we put distilled water inside. So this one is for CH3. So this is what we have achieved to solve the groundwater problem, because people are needing it, and sometimes we don't have to give people, and we don't have to help people. It is not good. People are suffering. That's why we think and get a big solution to help people in this situation. So just to inspire everyone who will need to help humanity to stop suffering. But this is for picture, and if you see now the distance here, so the distance, like it is big container, the distance should be minimum 5 meters between them. So five.
Okay, that's a good point. Yeah, that was brought up by Mr. Keshe in the last workshop, I think, when Caroline showed a GAN setup, and the containers were too close together and so on. Good point.
Yeah, so it is very important to don't let them close. Even when you let them close and you go inside here, between here, you put your hand, you can feel transfer of energy between this one and this one. Same for this one and this one. Same for this one and this one. Even 5 meters, you can still feel energy transfer between them. So now we are managing to go more than 5 meters. So it is very important, otherwise you will get mixing guns and other things inside. And I have one gas I have made experience with this. I put CH3 and I put CH3 in the bottle, and then I put also CO2 in the bottle, and I let them close. And what I have seen is what CO2 starts capped the atom of CH3 and have started changing the color. And now when you see this CO2, the color is totally red. So there is a transfer of energy from CH3 to CO2. So I have made this concept 2 months before, and I still keep these 2 bottles. And every day the bottle is changing the color, but CH3 is sending energy, or CO2 is capturing the atom of CH3 and starts changing the color. And I have considered that what Mr. Keshe saying about the stronger we give to the lower and the lower we take from the stronger is very effective. So when you let them in the transparent bottle, just grams of CH3 and CO2, and you let them about 0.5 meter, you will see this phenomenon. You will see that CO2 starts changing the color.
Good point, Paul. Thank you.
Thank you. So this is what I have to show you.
That was very good. Thanks. Appreciate it. Okay, I think
Just
we
a
need.
question.
Okay, questions. Go ahead.
We saw the bottles with the GANs, and you have a little bottle and a bigger bottle in order to get field interactions between them. And those two bottles you place apart inside the big container to influence the water, right?
Sorry, come back again.
Yeah.
Are you talking about this picture? Let me get the picture up here. Like this?
Yes.
Okay, well, he doesn't put them inside the container, I don't think. You don't put them inside the container, do you, Paul? You don't put the small containers inside the big container.
No, I have put the guns themselves inside. This is the tool for measurement for me.
Okay, so this is how much GANs you put inside. You pour it right into the container. Right? You pour this GANs into...
Could you formulate it another way? Are you putting the bottles with GANs inside the container, or you're just emptying the bottles with GANs into the water? Did Paul fill out?
I don't know, Paul, we're not hearing you if you're talking. Your microphone's turned off. Yeah, you're muted, Paul. We're not hearing you. Hello? Let me unmute you. There.
So
Hello?
I say I didn't put the bottle inside. This bottle, no. Only guns.
Right.
So this is just showing how much GANs you put into the water.
Yeah. And then you add distillate water and you wait for cooling down. And when you see, it is very interesting what you have to contact inside. When you see, for example, for CO2, copper oxide, maximum 24 hours, you can harvest these guns. It will cool down because of mass atomic of copper, which is very high. You will see that CO2 and zinc is around 35 hours to cool down because of their atomic mass. But CH3, minimum you have to wait for 72 hours before it cool down. It takes time to cool down.
Yes.
Because when you see, you can calculate the mass atomic of water and the mass atomic of CO3. It is not too heavy to go very fast like CO2. So when people say that CH3 is not cooling down, it's depending of atmosphere, field and atmospheric condition, and then the element you have inside of your water. And when you use, for example, distillate water for CH3, you will see that it's going very fast. Around 72 hours, it can cool down and you can harvest it. But when you use another water where you get other elements inside, it will go more than 1 week to cool down, because there is interaction of different fields inside of water, different interaction of field from the elements inside of the water and the CH3.
Good point. Okay, thank you.
one last question. What do you do when you tap the water? How do you avoid that the gas comes out with the water? Because
Yeah,
I
when
saw
you see,
the
yeah,
the place you tap the water is quite low on the container.
no, please come back in the picture where I get the four. So when you see this, sorry, when you see this,
Yes.
this one, the level I make it here to there, I let about 8 liter, and gas is 2 liter. So we have 6 liter of difference between them. So impossible to get gas inside. We have calculated everything before making it.
But then you tap the water very slowly, right?
No, when the guns cool down, the guns will stay here at this level. And then you had security parameters, so you let some liter. That's why there is C liter, where you have some water you cannot harvest, and then you cannot touch also the gun.
Yeah, actually,
So
the proper method, Paul, that Mr. Keshe talked about was you take the top 10% of the water out of the container, not the bottom part like that. You're supposed to take the top 10% above the. Let me annotate so we're clear here. Oh, I can't for some reason right now. Won't allow me to annotate, but. You're supposed to take the top 10% as the way I understand it. Not sure how you got that bottom part there that you're supposed to take it from. So like there'll be a gradient in there, and the idea would be to take the you know, the top couple of liters, let's say, out of a container like that, top few liters. Maybe the top third or something even.
But couldn't we do it another way? If we had a plate inside the container with a lot of small holes in it, and in the center of the plate there's no holes, and then you add water slowly to it in the middle of the plate, and then you have no circulation near the GANs, so it doesn't get stirred up. Then you could add water at the top at a regular interval and tap it from the top also.
But you want it to impart its fields though to the water through mixing it with the water though, I think, rather than just having the water sit there. Don't know. And plus nanomaterials go right through holes, so that's not going to stop the although, you know, it'll stop the agitation, turbulence, and so on. It's true.
I think that the fields will come up in the water even if you don't stir up the GANs, wouldn't it?
Well, perhaps, but the idea is that you mix in the water, the still water with the GANs, and you let it settle, and you take off the top 10%. You can warp and twist the ideas all you want, but that's what I've heard, and that's the way I understand it. Does anybody else have a different understanding? Am I not clear with that, or is someone else have a different understanding of what Mr. Keshe said about that, and others?
I think you are right. I heard the same as you say.
Okay, just a little detail that Paul, you might want to try a different technique there if you're using all that bottom GANS water.
Okay, so I can also try to put a pipe here. Pipe here.
Not seeing the picture there. Yeah, okay.
And then put small pump, mechanic pump, and then drop only this one out. I can make also this technique.
Yeah, that could work too. Yep, there's I've used a soap container with a pump on the top of it and just cut the hose off inside the soap container, cut it short so you only pump the top third or quarter of the contents instead of the stuff at the bottom. And then you can reuse the soap pump for GANS water pump or plasma water.
I can try it.
Yep, that's a good idea, I think. All right, let's. Is there any more questions, or can you let me go? We're fading here. It's 3:30 in the morning, or 2:30 in the morning, and we've been at it for 4.5 hours. So perhaps that's good enough for now. Let me get my video going here. And oh, there we are. Okay, well, I think we had a pretty full evening here with lots of explanations and lots of detail work, and especially some of that explanations with Armin there that were good for the nanomaterials and the layering of the nano layers, and that can be useful for our animation team to help put together some sort of coherent animation to show the nano coating process, which is important for us to do so that we don't wear out Armin's arm when he has to make all these little circles with the mouse, which is always hard to do, and so on. And we'll have a little animation that when the question comes up, we'll just show it, and then it'll all be clear to everyone, which is what we try to do here. Try to clarify more and more as we go along. So thanks for everyone's clarifications today. And I think it's clear we're at the end, and we'll have to Doug gives a thumbs up. Okay, thank you, Doug. And oh, I'm just going to show my picture instead of just the share here. Whoopsie, let's get this straightened away,
and I just want to say thank you very much to all of you, because this has been a gem today. There has been so much good information here, worthwhile looking at again.
Yes, thank you, Eric. Thank you for your participation and questions and so on too. It helps to stimulate things when there's a necessity there. That's the important part, is someone has to need to know in order for that transfer of information to actually take place, which hopefully some did take place today. I know it has. So thank you all, and once again we're signing out from the cold northwest here. It has been cold, I'll tell you, it's been cold, and the wettest March ever recorded in weather history. And it's probably the coldest winter we've had as well here. It's been interesting, let's say.
Thank you, Rick.
But the plasma keeps going, it keeps us going, keeps us warm in our hearts. That's the important thing. You had something else you wanted to show there, Plasma Head, as well, right? Or do you want to do that next week, or how are you doing? Did you get an answer, or what did you have to show? Sorry to cut you off, I just remembered. You still there, Plasma Head? Did you want to show something, or?
Well, I'm trying. I'm just experimenting. I'm doing. I'm trying a new method of nano coating. Actually, it's an old method, but adding a little bit to it. And just wanted to get some ideas, you know. But
well, if it only take a minute or two, we could whip through it.
All right. Yeah, it won't take a minute.
Okay. Okay, you're gonna show your video? Is that the idea? Okay. Let me just get it set up here.
I got my
there we go.
I got my coils inside here. First, I soaked in potassium hydroxide and sodium hydroxide for about a day, and then I hung them and I put a copper plate in there in the center, you know, and tied it to this. And the coils are hanging, and I hooked a pain pin to the back of it to the copper plate that's in there, going in, and tied these nano-coated wires to the top of the coils, the magnetical going in. And man, this seems to be doing really great. I added this to it too, you know, just to see where to pull, you know, more from the environment. But I just thought that was pretty cool, and I'd like to see if anybody had any ideas, something, you know, that I could do better, or just what they think. But I mean, try and open it. Just.
What's your intent?
For it to be more of a plasma.
A generator of plasma.
But
okay.
Just feeding the coils with the plasma. You know, I've been discharging it, and every time it seems like it's taking longer and longer, and then sometimes it won't even discharge; it just stays, or it'll continue to bring the volts up or whatever. It seems pretty cool, but it's just an experiment.
Okay, thank you for sharing. Is there any other comments about that? Anybody want to give them any advice or questions? Do you have GANs on that, on your coils and so on in that, or is it just straight?
No, it's just nano coating itself now.
Okay, right, yeah. Well, that might be something to consider, is the what ganses you want to have on it, what kind of connection you want to make with that coil. Is it something you want to get real up and personal with, or is it going to be just a nano-coated kind of non-organic coil set? How lively do you want to make it?
As alive as it can be.
Well, you might have to add part of yourself to it in that case, in the sense of, you know, possibly some sort of amino acids or some other things that add to it. Like in the case of Frankenstein, for example, he needed to add a little, had to have the flesh there, and then add a little lightning to get everything going. Whatever it takes. A little bit of amino acids and maybe some static electricity.
Having crawling coils coming alive.
Hula. Coils with feet. There's a scary idea. Okay, I gotta make feet and walk out of here now. I'm losing it, getting too tired, so thank you Sane or plasma head, whichever you like to go by. And let's call it a night for now. And once again, thank you everybody for attending the Keshe Plasma Reactor Group for what's now is Wednesday, April 12th, 2017. And we'll see you all here next week with more reports on what's happening in the world of plasma. Okay, bye for now. I'm going to sign out of the live stream. And we'll